Hello, hello chat. Can you hear me? Can I get an audio check? I changed my audio settings again. Can I get an audio check to make sure there's BGM and then you can hear me and then two. Actually, I just realized I don't know what to call you here. Do I call you two? Do I call you Matthew? Do I call you Mr. Yeager? Do I call you Chicago?
I go by Thew.
Thew. Okay. Can you hear him? Say something again.
Hello, video games.
Video
Technology.
games. Video games. Technology. Video game technology. Actually, I should just listen to my stream real quick. Let's see.
The icon is lighting up.
Need to mute my audio real quick. Yep, everything seems to be working correctly. BGM is there. Guest seems a bit loud. You sound good. Oh, really? Do I need to raise myself a little bit? Oh, no, no. OBS says I'm pretty loud. I guess I'm just a little bit soft. I'll just raise my mic a little bit. Boop, bloop, bloop. There we go. And we'll raise this. We'll raise this. Okay, that should be a little bit better. I'll adjust over time. Hello, Otto. Hello, R. James. Hello, Funky. Hello, Monochrome. How's everyone doing today? All right. Welcome to. Do I have a name? Do I have a name for this? I don't think I have a name for this yet. Welcome to Jada Game Dev talk about game dev topics and potentially biosoftware engineering and biohacking and how our jobs suck and are awesome in other ways. But you know, welcome. This is Matthew Yeager. Can how do I introduce you? Like, do I introduce you as the Aerobat guy, or would I give you PTSD?
I'm basically the Aerobat guy. It's just not done yet.
Okay, yeah, because I wasn't sure. Like, so I know, but whenever someone asks me, "Hey, is Mahou arms done yet?" Like, you know, part of my brain goes like, ah! You know.
Someday it will be done.
Yeah, this is Matthew Yeager. He's working. He's on Twitter as Amazing Do in one word. He's been working on Aerobat for a long time. That's how I found him. I don't remember what tweet in particular I found him on, but I probably saw it and it was like, whoa, this is cool. And then just gradually start talking to him more because I have no game dev friends. And I just wanted to bring him on because I haven't really had anyone that's like a full-time game dev on here besides myself, like, and just haven't like been able to just talk to anyone on stream about game dev stuff. So yeah, this is Matthew Yeager. Welcome.
Hello.
Can you give me a general background? Like, when did you? Oh wait, I should probably tell them what I'm working on now. So I'm working on this thing called in Mahou Arms. That's the a traversal mechanic. Basically, a level designer told me they needed something like the phase gate in Gaussian, or I think it's like the gravity cannon in Apex, where they send your character like to a really far distance. And they needed something like that, and I bounced ideas around with you actually to try to figure out what to do, and ended up on this butterfly cannon thing, and I'll show you what it looks like now. Not done yet. Oh, there we go. So if you go into here, you go like this. When you interact with it, you can aim at the potential targets you can send your character to. And then once it's done, when you press the launch button, it'll like send your character in a cloud of butterflies and then like explode at your destination. But it's not done yet. You can see the game just stops working here. Yeah, so that's what I'm working on now. This is just the prototype. I'll be programming this today and trying to get the rest of the gray box done. I have a couple concepts here actually. Let me show you real quick. Oh no, you can see my OBS.
Oh.
This is the concept for the butterfly cannon. I'm not sure I'll get to the art today, but I'll try to get the prototype working at least. Here's a little design document I made that I'm not sure you can call this. I guess you can call this a design document, just a bunch of doodles for like. Sometimes like when a mechanic is complicated enough, I can't make it without. I can't program it without like having like a little diagram like this. So this time I actually made this. I don't always do this, but this is here. Hey, Tengen. Big audio mixer. Yeah, big audio mixer. Can I tell you computer audio is like a fucking like nightmare? I was telling you about this earlier, but Look at this shit. Like, look at all this shit I have to do just to separate my audio tracks between VOD and recording. Like, look at this. Oh, no, I don't want to donate voice meter. Okay, there we go. Like, look at this. There's so many audio mixers. I hate this. Okay, anyways, I'll close it. Hope that didn't break anything. Alright, dude. I know you do Aerobat. I know what you do for a living. Can you give me a general background of what you do?
Yeah, so as we said, there's a video game that I'm making that's called Aerobat. I guess you could Google that if you want to find out about it, but it's not done yet. I've been working on it for like 9 years. But also, I've been working in actual video games. I work at a company called Level X, and we make games for doctors, which is a very weird niche. But it's like this weird combination of like some of the stuff we make is just games that are like out that you can just play, that are like sort of video gamey representations of actual medical procedures, and then we also do a bunch of more serious like training simulators and stuff that are for like medical device companies, so they're not really released publicly, but they're like, it's like work for hire stuff. It's not a huge studio.
Yeah, it's like it's my understanding that there's really two paths that like game devs go into. It's like either we make games, we make Call of Duty and like Peggle, or like the second path is like we work for the government and they pay us like billions of dollars to train people how to kill other people. So,
Yeah.
And well, that's the simulation sector is what I'm trying to explain. But like it also felt like there's also medical simulation sector, and I didn't realize there was a third sector, which is like you have doctors that like playing games about being doctors, and I was like, wow, doctors can want to play games about being doctors, and that is my understanding, and that's what you're working, right?
Basically, yeah. I have the same concerns that like I don't think a doctor who does heart surgery all day is actually going to want to go home and play a game about heart surgery.
Yeah.
But we made one of those anyway, so what do I know? But like, well, really, I mean, most of the actual money comes from the work for hire type stuff for like pharma companies and medical device companies and things. So it's not super glamorous, but like a lot of the tech stuff that I get to work on is very cool. Because I'm like primarily a graphics programmer. So I got to build like a actually physically based X-ray simulator, and then had to build like a reasonably physically based ultrasound simulator, and we get to do a lot of like wild stuff with like soft body physics and like fluid sims for like blood and like mucus and lots of like super gross like surgical stuff, because it's a very weird like the types of materials and interactions and stuff you end up with in like medical and like surgery spaces is different from a lot of video games, unless you're making Mortal Kombat.
I never thought about this, but the way we can talk about this more later. But the way ultrasounds work and the way X-rays work are literally the opposite, aren't they? Like the ultrasound, like it's like a low radar, and the X-ray is like it goes through you, right? So
yeah, X-ray is shadows, ultrasound is backscatter, not reflected. We can get into that, but yeah.
Oh my God! Wait, it's not reflected? I thought it was reflected.
Oh boy. Okay. Do we want to just start on how does ultrasound work?
Let's save that. Let's save that for later. Let's see what we have to talk about. Actually, yeah, just go ahead and talk about how ultrasound versus X-rays work, because I thought about it and I was like, wait a second. I don't even know how. Like, even in the real world, I don't know how they work. Like how do you?
I had to. It took me literally a year to make that ultrasound sim, because I had to do it. It was like me and one of our like biomedical researcher people, and the two of us just trying to figure out like everything we could about how ultrasound works. And what it turns out is that like everything on the internet about how ultrasound works is wrong.
Oh no, it's like that time when I tried to do sphere tracing, and then I realized everything on the internet about sphere tracing was wrong, and then it took you like 3 days of yelling at me in like a matter like a graphics programmer yelling at an artist how to do graphics programming to like for me to realize that everything on the internet about sphere tracing was wrong.
Only some of it is wrong. There's just no way to tell which is correct and which isn't.
Turned out everything I was looking at was wrong.
IQ's stuff is all correct, but he doesn't actually tell you how to do the sphere tracing. He just gives you all the distance functions. And doesn't name any variables.
He just works. IQ works for chat, IQ is like how do I explain Inigo? Is it Inigo Quiles? Is that how you
I
pronounce his name?
guess. I don't know. He's Spanish. I don't know how you pronounce his names.
I can go ahead and open his webpage in the meantime. Inigo Quiles is like you know how Newton in his time invented calculus, right? And like calculus is like I don't know. You guys probably don't realize how important calculus is to like literally everything we do. Like computers probably can't exist without calculus. Like I know computers are mostly like linear algebra machines, but like there are some things that you need some like calculus function to make the things that like to get some of the results in computers in a way that makes sense. And yeah, this page that I'm on is called the distance function page, and I think probably like maybe 50 to like 60% of, maybe not 50, maybe like 30% of graphics programming, like 30% of all graphics programming that exists in the world right now references this website, like this page on this website.
You just
like,
have this page open in a tab all day.
Yeah. Like I'm sure at least one person has converted this into like giant poster form. Oh hey Kaite, thanks for the raid. Hope you had a good stream. Yeah, like it's just like this page is so important. Like it's because this guy just all day, all he does is sit here and go like, yeah, I'm gonna how do we know where a sphere is in space? From like on this pixel, is there a sphere here? Let's make a math function that gives us that, like without having to do anything, like without having to render any triangles or anything. Anyways, yeah, this is all super important. So okay, that's a little aside. So I forgot why I went on a tangent.
Because I mentioned him as a website that does actually have correct examples for ray marching stuff. But yeah. Yeah, I guess the easiest way to explain the X-ray and ultrasound simulation is start with X-ray, because X-ray is actually like pretty easy to understand. X-rays are just shadows. Like you have an X-ray emitter on one end, and you have a plate on the other side of the patient. And that plate either, like it used to have film in it, a lot of the time now it's a digital, it's not actually a CCD, but it's like a CCD. And it's big, it's like a few inches across usually. It's like the size of the part of the patient that you want to X-ray. So the X-ray gun shoots X-rays that are collimated, meaning like all of the waves are parallel. It doesn't really spread out very much. It's sort of like a laser, but like big.
And this is important because you'll get fuzzy shadows otherwise, right?
You get perspective distortion.
Oh, right.
Yeah, so the X-rays go through the person or whatever else you're X-raying, and as they pass through generally denser material, they will be absorbed by that material, which means they don't continue on to strike the detector, which means the part of the detector that's behind like a bone or something is darker. So an X-ray is literally just a shadow. An X-ray is a light, like it's a very, very high frequency light, but it's a light. And like it shines through people because people are mostly translucent at that wavelength. And the person casts a translucent shadow on the detector behind them. And then that detector goes through some like processing and stuff to display an image.
This gets sound really dumb, but an X-ray is basically just like it's just a really high frequency, right? Or the low frequency. Okay, it's high frequency. It's like the opposite of a microwave, right?
I'm actually I'm gonna have to Google this now. I don't actually remember which way. I think of it in terms of energy, because like the variable that you play with for X-rays is what the energy of the beam is, which is the amplitude of the wave, not the wavelength. So I'm suddenly realizing I don't actually know what frequency range. Yes. Okay. Very high.
It's low because it's radio. No, I don't think it's low, but I just think
it's
about
very
it.
High.
Okay. So wait, 'cause I thought about it just now, and like it technically, like what do you call it? Nominally, a lower frequency wave has an easier time going through objects. So, and I don't actually know the physics of why X-rays are high frequency, but that's just something I never thought about.
Yeah, that goes beyond my physics knowledge too. Why specific things are opaque at specific wavelengths? Because like it gets really into very elaborate like material science stuff very quickly. But the main thing you need to know is that like it's light, so it behaves like light. The only thing is that like in that frequency range, it's dealing with translucent objects. So like nothing really reflects X-rays like at all. Like even metals won't give you like a mirror reflection for the most part. They'll give you they can like scatter it a whole lot, but even then you can't really like make an X-ray mirror or like an X-ray lens even. So like the if you have a wave, the main things that can happen to a wave are when it interacts with a material are reflection, refraction, absorption, or scattering.
So let me just really quickly summarize. Let me try to understand what that means. Reflection, it bounces back, you know, in at the reverse angle or whatever normal it is. Refraction is it goes into the object and out the other side, but it's bent. What was the third one? What's the third one?
Absorption.
Absorption, so it gets stuck inside the object. We're talking about photons, by the way. And
yeah,
what were the last ones again?
Scatter, which is the most complicated one.
Oh, so basically, so scatter it every photon picks a random spot to bounce off in a goes off in a random direction in a different spot, right?
Yeah, in sort of a cone, basically. So like with it's pretty easy to think about with visible light because you can think about real objects because like anything that's visible reflects some light. Like that's why you can see it at all, right? Like light bounces off of it and bounces into your eyes, and so you can see it. So even like glass has reflections on it. So everybody understands reflections for the most part. Everybody also mostly understands refraction because again, glass, water, like the rays go in, they get their direction gets bent, but they all get bent the same way, which is like based on the viewing angle and angle of incidence with the normal and stuff. But like a refracted image is still a clear image, right? Because the rays that were parallel after being refracted will still be parallel. Absorption is also like fairly easy to understand because that's basically just like tinted glass. Tinted glass is transparent. It has some reflection, it has some refraction, but it also darkens everything that passes through it because it absorbs some of that energy.
So the interesting about it absorbing the energy is that, so is it absorbing, so let's say a piece of glass is red. Is it absorbing everything except red?
Yep.
Oh, okay.
Yeah, and that where that energy goes is it becomes heat.
Oh wait, it becomes heat? Really?
Yeah, that's why light heats stuff up.
Oh, I know.
It doesn't become very much heat, but it does. Like that's where the energy goes when it's absorbed.
I never made that connection, but you're right. It does have to become something, and heat makes sense because it's no longer light anymore. Okay.
Yep.
Oh my god. I just a little aside. I have like, I've been trying to program here while talking to you, and it is not working. So keep going.
Dude, I cannot program and talk at the same time. I thought you said you were going to be drawing, because like I can draw and talk, but like I can't. That's why I don't stream, because like I can't think about dev problems.
I am not set up to draw right now. So that's okay. I'll just program extremely slowly. Go on, keep going.
Yeah. Oh yeah, somebody said in chat, is that why black paint heats up more? Yes, because it reflects less light, and it doesn't transmit the light because it's not a transparent paint, so like it has to go somewhere, which means it's absorbed.
Someone earlier also said that you also make video game analyses stress that are incredibly on point. Yeah, they're very interesting. I sure wish you were a streamer.
Yeah, but then it's on Twitter. You can just go read my tweets about JRPGs instead of watching me play them.
We need a due thread archive, TTA.
Oh, there's another interaction, which is transmission, because I used that word and didn't call it out. Transmission is just the light goes through and nothing happens to it.
So like glass?
Yeah, but also like glass also reflects and refracts, but some can be transmitted. And then the last one is scatter, and scatter is like harder to reason about until you start thinking about these things a lot. But scattering is that instead of being refracted, the rays are bounced at random angles. And so if it goes in like in a straight line, it might get bounced in any new direction up to some number of degrees. So like in a cone, basically, like all of the photons get bounced out of their original direction. But some materials scatter more than others. So a material that doesn't scatter very much doesn't displace the direction of those photons very much versus something that scatters a lot. The easiest one to think about for this is like frosted glass, or like a shower curtain that's like translucent, or glass that has like condensation on it. Like you can still see through it, but you can't. Everything behind it is blurry, because as light passes through it, that light that was parallel gets scattered in random directions, and so it becomes out of focus. And so like, because it's a cone, like if you put like your hand up against like close to the glass and look through it, your hand will be in focus, like not blurry, but then things that are further back are more blurry, because over a longer distance the scattering spreads out further.
And what do you call it? And the reason why things are blurry in the first place, even for contact outside of scattering, is the rays are not aligned. Like they're not parallel to what we're looking at, right? So
right.
Yeah.
And then you get into like lenses and what lenses do, but that's a whole different conversation. That a lot of this gets very hard to explain without me being able to like share my screen and draw a bunch of pictures.
I can, if you share a screen, I can try to show it on the stream as well, if you want to do that.
We don't need to do that right now.
It's fine.
So,
Dude was like, I don't want to do more work after I finish my work already.
I like explaining this stuff. This is always fun. So like, that's how light interacts with like visible surfaces for the most part. And you get into like the sky is blue because of scattering, and like clouds look fluffy because of scattering.
And then there's different kind of scattering, and then because scientists all have massive egos, they all decide to name them after themselves instead of clear names, you have like Mie scattering and like Rayleigh scattering, and I never know which one is which because the scientists always like fucking like they all have egos.
In fairness, they're different because they're both describing scattering, but they're describing scattering from different physical processes. So like the distinction does matter, but yeah, like refraction is pretty, like the math that governs refraction is just Snell's law. Like you can read Snell's law and understand it if you know. I don't think it's even calculus; it's just basic geometry. But yeah, scattering is like you can make your entire career as like a PhD research guy in just like some subset of how scattering stuff behaves. It's wild. So all that to say, that is all context for X-rays are shadows. Everything is translucent to an X-ray light. So like you can imagine everything kind of being made out of glass, and like tinted glass, which absorbs a lot, will cast a shadow. So when X-ray passes through a material, some part of that energy is absorbed, which leaves a shadow behind, and that's what an X-ray is displaying.
Wait, so you're telling me that that if you X-ray someone with a lot of X-ray energy, if they don't die from cancer, you can die from boiling them? Because theoretically,
very little. Yes, I mean yes, but no, because it doesn't actually make that much heat.
Oh, okay.
But yes, like you do heat someone up with an X-ray. That happens.
My new patent is an X-ray space heater. Personal space
notably,
heater.
this is not what a microwave does. Like the way that a microwave heats thing has to do with like vibration stuff and not actually like absorption. As far as I'm aware, I haven't looked very far into that, but I don't think the way a microwave works is
There's a common
from
misconception
absorption.
about a microwave too. Actually, people think a microwave heats stuff up from the center out, but it actually heats everything about an inch or like a centimeter below the surface. So the stuff in the middle actually still stays cold until you heat it up with it. So it's heating a certain distance from the surface. It's not actually heating at the center.
Someday I'll have to make a microwave game, and then I'll learn how microwaves work. So the interactions that the X-ray can go through as it's passing through the person, like it can be transmitted, which means like nothing happens, and that happens a lot with X-rays because they just kind of don't interact with things very much because the wavelength is so tiny. It can be reflected, but as we said, like X-ray just kind of doesn't reflect off of most materials, like for whatever material physics reasons, whatever the processes that cause surfaces to reflect visible light does not cause those surfaces to reflect higher frequency light. So nothing really reflects X-ray. Nothing really refracts X-ray either. So you don't really have to worry about that. Everything absorbs X-ray. And generally speaking, the denser the object is, the more it will absorb. And that's like, if you Google how does an X-ray work, like everything will just say that it's like denser objects appear darker under X-ray, which is generally true, but like specifically how much a material absorbs has to do with like other physics things. Like objects with the same density can actually have different like attenuation coefficients, but like this is like
the primary thing about graphics programming that I don't think most people understand. It's like like everyone understands intrinsically that like when you hit something with like the specular thing on an object, like specular highlight on an object, for example, or like it's not quite it's on a different position than the diffuse light, or like you know that when light hits like an object, it becomes like lighter, right? And where the shadows are darker. But like the graphics programmer has to go in and go, but how much?
Yeah. Largely an unsolved problem.
Hey, we have good approximations for it though.
Yeah. So reflection, refraction, absorption, scatter. We just said reflection and refraction don't really do much. Absorption does a whole lot, and that's why you got a shadow. Scatter also happens, and that's where you get the weirder interactions of like metals will like totally fuck up an X-ray and stuff. And like part of that is that like in addition to being super dense and absorbing a lot, but they will also scatter. Fortunately, all that scatter results in an X-ray is it gives you a blurry image, right? Because the rays have been diverted randomly from their original path, so you get blur.
It's essentially the same thing as looking at something, except it's X-ray. That makes sense.
And you're looking at the shadow cast by a thing. So frosted glass will cast a blurrier shadow than tinted glass that is not also frosted. I doubt anyone has some like sitting in front of themselves to test that, but like that is how it works.
I mean,
'Cause,
someone
like,
could have. Someone could
you
have
always
a
have to
cold
remember
drinking
that like
problem.
it's always shadows.
Okay, I get it now. So how did this tie in? So how did this tie into ultrasounds?
I have to finish this thought first.
Okay.
Which is that you can eliminate scatter from an X-ray, because all you have to do is just put a collimator in front of it, which is a collimator is a hilariously simple piece of equipment. If you want a way to ensure that all of the light passing through some kind of lens type thing is parallel, all you have to do is make a big grid of like black fins. Think like a heat sink.
Oh, I get it.
That's all you need to do, because if it's black, it absorbs light, and so if the light isn't parallel to the fins, it will hit one of the fins and be absorbed. So the only light that can make it through a collimation grill is light that is collimated. All the rays are going the same direction. You lose a ton of energy doing that, obviously, but it guarantees that the light coming out the other end of a collimator is collimated.
Yeah, it's okay. Just use a stronger X-ray.
Yeah, so you can do that. You can
More
do that with
radiation.
X-rays too, because again, lots of stuff absorbs X-rays, even if it doesn't interact with it in other ways. So you can just slam a collimator on over the detector plate, and then that solves the scattering problem.
Why the detector plate and not the lamp? Is it because you get like slightly more focus that way on the detector plate?
So the light coming out of the lamp is already more or less collimated, but it can be scattered by what you're X-raying, bones and stuff, and the person scatters it. So to make which would make what hit the shadow that hits the detector blurry. So to make the shadow not blurry, you put a collimator over it. Which means, surprisingly, it's not actually very hard to build a physically accurate X-ray simulator. Like, once I learned all of this shit, I was able to do it because since there's a bunch of equipment to eliminate scatter because you don't want scatter, it means I don't have to simulate it. And scatter is really, really hard to simulate. Like, that's why like video games are like just now starting to get volumetric effects and stuff, because like it's so fucking hard to do.
So easier for you to make
simulation.
it because it was so easy for you to make a perfect X-ray. I see. Okay.
So what I had to do to build the X-ray sim is assume all rays are collimated, and then like figure out how much material the ray has passed through. Do all of the attenuation math to figure out how much of it is absorbed, which is thankfully like well understood, because like people need to know that in order to like do medical stuff. So you can like go look up experimental values for like what is the attenuation coefficient of all these different materials, and
But then you have
like,
to
how
convert
does
that into like pixels. But you have to convert that into like luminance and stuff. Okay.
Yeah, it's really fun actually. Like the code that I wrote, like you have a render texture that represents the detector plate that has like the shadow being cast on it. And what the pixels, it's like a floating point render texture, and like what the pixels in that render texture represents is kilo electron volts. It's literally like the energy from the X-ray that's striking the detector. And so like 70 keV is like the normal energy that most X-rays operate at, but like the attenuation itself from a material depends on what the energy is. So you have these like lookup textures that like encode all of these curves for like if your X-ray energy is this, then the attenuation coefficient will be this. If it's a higher energy, then it'll attenuate more or less depending on what the material is. And those are all values that like scientists have figured out, so I can just use them. So then you simulate your light, you do all of your math, and it's all just like shader stuff. And you end up with a render texture that is literally just like how much energy is striking this plate. And then do a bunch of post-processing from there. Like you have to tone map it then, which actually hilariously, like video games have tone mapping already. Like a whole lot of or rather, like this discipline has tone mapping already. Like a lot of stuff that an X-ray machine does is like taking those voltages and converting them into like an image that you can display on a screen. And the algorithms for doing that are all like proprietary stuff. So like Philips or whoever like manufactures these things all does them differently, and it gives the operator a bunch of knobs for like exposing things differently, and has a bunch of like automatic modes and stuff.
And it's basically just a tone mapper. Huh.
Yeah, it's just a tone mapper. Like I just threw fuck, I can't remember the name.
Unity tone map.
But it's not. No, it's. I mean, it's a curve that I had to do in math, but it's not ACES because ACES is weird, but it's another one. But yeah, it's just like a well understood curve that games use for tone mapping, and then like,
ACES a film tone map curve, or that like a movie film tone map curve, or that like something else? Or that come from like photography? Okay.
It comes from it's like a standard for film processing stuff, and it's a tone curve that is similar to the way film generally responds to light, and it's used for like standardizing a tone map curve across a bunch of different digital sources in one project. The way games use it is based on kind of a misunderstanding of how films use it, as far as I'm aware, but I don't know how films use it either.
Just as a little side note, every time I ask you to explain something, this is what happened. I'm like, hey, can you? So how does light work? Like how does rendering work? And he'll just go. So to explain rendering, you have to explain how the universe works.
All of this, well, because you're asking about things from a graphic standpoint, like.
Yeah. It's fine.
Unfortunately, everything gets complicated as soon as you start. As soon as you have to simulate it. But yeah, so you just tone map it, and then like they do some like high pass filter stuff, which is really fun. Which is like a high pass filter is actually just like a Photoshop sharpening filter, except with a little bit of extra math. And so like I threw that on there, and like it looks real good. And it's like, I don't know, I could find a screenshot.
I don't know if I have them on hand, but it did look super cool when I was looking at it. I'll put it on my stream as well. Ooh.
It's in one of these windows.
I like how we still haven't figured out how ultrasounds work.
Yeah, that's a harder topic.
Oh my god.
Here we go, I found it.
I completely broke my code. Why did not spawning? Why are you? Oh, I know it because I didn't assign this. Okay, there we go. Hey, is Snape a bad guy? Well, to decide whether he's deemed a bad guy or just a misunderstood character design, let's observe the entire Harry Potter book series. So Monochrome, that's almost correct. What he would say is so let's explain what bad means. And let's explain what bad means, and let's explain what guy means, and while we're at it, let's explain the English language. It's like, let's see. Hack those tables and oh yeah. He posted a link.
Yeah, it's like part of a thread where I was like explaining how a bunch of it worked.
Yeah,
yeah, that's what it looks like.
Pretty convincing X-ray, right? Except, like, the only unrealistic part about this is you never be able to get someone to sit still like this and then get like a full 360, like super smooth 360 scan of their brain skull thing, you know?
You can do it with a CT.
Oh, is that what a CT is? But CT doesn't use X-rays, though.
If I explain what CT is.
Yeah, CT doesn't use X-rays, right? It uses something else.
Yeah, it does.
Wait, really?
CT literally spins an X-ray around your head or your body, because again, you need an emitter on one side and you need a detector on the other side, which is why you sit inside of a donut for a CT, because one side of the donut has the detector and the other has the X-ray gun. and it spins like terrifyingly fast, and it shoots like a 360-degree X-ray of you at one shot, and then does a bunch of like incredibly cool math to reconstruct a 3D model of like a three-dimensional X-ray.
What is the
It's
maximum
very cool.
frame rate of a CT scanner? Is like 30, 60? I'm showing.
Much
I'm
higher
showing.
than that. I don't know.
I'm showing the chat what a CT scanner spinning at full speed looks like as well. These things are fascinating. I love these things.
Yeah. No, they shoot like a few hundred exposures in like 1 or 2 revolutions, I think.
Really?
Like, it's like nearly instant.
Yeah, but that's exposure.
The faster it goes, the less opportunity you have for motion artifacts, because the patient is like breathing and like can't ever sit like totally still. So you want to take every shot as close to at the same instant as possible. So the faster you can do it, the better.
I want one of these machines.
Yeah. I'm always like, why is all that equipment in the spinning part? Like, why would you not put all the equipment, all the big heavy stuff, like in the base of it, and then just have like a big slip ring or something to like only put the components you need in there? But
I'm guessing it's a. I'm guessing.
engineer.
I'm guessing it just a really. It would just be a really big, like expensive slip ring, considering how much data has to be piped through.
Yeah, but these things cost like millions and millions of dollars, like. And also, like, everything that's in the ring needs to be balanced. Like, all of those components look like they're just thrown all over wherever they'll fit, but they're balanced because it has to be able to spin at insanely fast. So, like, the center of gravity of that whole pile of parts is dead center of that machine.
I'm guessing it's simpler to engineer a bearing and structure and balance that will hold everything like that in one place, as opposed to engineering a slip ring that will work at those revolutions without other problems. I'm guessing that's what it is, because most slip rings only really work at really low frequencies, right? Like they don't like, the faster you go, the more likely your slip ring is to break. I'm guessing what it is. Also, like don't even. I mean, I said slip ring, but like you can do it with a radio connection and stuff too. Like there are lots of ways to get data out of a thing that rotates. That's true, but I actually know a radio connection. Oh no, wait, this isn't an MRI, so it wouldn't be affected by electromagnetic interference.
Right.
Yeah, I don't know. You raise a good question. Radio next to the very big wideband magnet. No. This is an
MRI
this is a CAT scan.
is a different big spinning machine.
They both spin.
I don't think an MRI spins, although I'm not actually sure.
Doesn't it?
But it is a big donut.
Let me look at this up.
I did try to learn how MRIs work, basically on some like downtime between projects, and I got like really far into like learning how two-dimensional Fourier transforms work, because MRIs create images in Fourier space. Like they create a frequency domain representation of what they're scanning, and then that has to be like inverse Fourier to render an actual image, which is wild. I did not get far enough into studying that topic to understand like what kind of machine like natively functions in frequency domain. That's like super weird to think about.
This is yeah, so it looks like the MRI does spin. I went and looked it up while we were talking about this, and it's really funny because this I can't help but this Philips MRI looks like a giant flashlight. It's like, why? Sorry. Here, I'll show you what I mean.
I've got the stream open. I can see it. Why is it so fleshy? What the fuck? Why would they do that?
Right, the whole thing is even the little the PP that goes in is like a flesh colored like fabric on it. It's all flesh. Sorry, go on. Do you want to explain what a Fourier transform is, or is that too much?
That is too hard.
I don't think I will be able to do it either. But it's like, what do you call it?
F is for flesh.
Flash MR, flash magnetic resonance imaging. Okay, go on.
I tried to explain Fourier space to you one time, and that took like I like should have gone to bed, and instead I was just like sending you messages about math for like an hour. And I didn't even get to 2D Fourier transforms, which is where all of the MRI stuff operates. So yeah, let's not do that right now.
I watched I think I watched like 3 hours of videos on Fourier transforms. I still didn't get it.
As soon as you have a use for it, as always with this shit, as soon as you have a use for it, it's very easy to understand. But if you're just like, if somebody's just telling you about it, or like, God forbid you're in fucking college and like have a lecturer just being like, and this is the Fourier transform, and this is the inverse Fourier transform. Like, you never learn it. As soon as you need it for something, then you're like, oh, I get it.
Okay, 1 second, I am doing some math real quick. Okay, yeah, someone asked, is this the guy that you said would make me completely confused? Yes, because he makes me completely confused. and I think I do more programming than most of my chatters, so if it makes me confused, I think it's bound to make most people in my chat confused.
I have found myself just like, all of my knowledge just becomes constantly more esoteric. Because like I'm a graphics guy, which are already just like all weird people, and then like my job has me like learning all of this weird shit that like nobody else knows about. Like the ultrasound stuff, like we eventually just hit a wall with it because like nobody I work with like knew how it worked, so like they couldn't help me with anything, and like we have like medical researchers, but like they know how to research stuff, but like none of them are like domain experts. So like they were looking at the same resources as I was. We eventually like contracted a guy who does actual research on a bunch of like backscatter ultrasound, like not ultrasound images, but like specifically like analysis of backscatter patterns in an ultrasound context. He's like doing research at one of the Chicago universities. I never remember which one, because like one of them's the University of Illinois and one of them's the University of Chicago and one of them's the Illinois in Chicago or some shit. Like there's like, they all have the same name. Anyway, we like, I just like, we found a guy who who's like an actual medical researcher who's an expert on this topic, and like paid him to like talk to me for like several hours to like explain shit that I just could not research on ultrasound. So yeah, like now I have all this just like increasingly weird knowledge the older I get.
Wait, so I guess we're not going into ultrasound, I guess.
I mean, we can. It's so complicated.
Okay, I can just explain to chat that it's like sonar, right? Sort of, it's like radar, which is the same as sonar-ish.
Well, I will try to keep this brief because it's insane to try and go into this, particularly without having like visual stuff. But that is the thing that everything on the internet is wrong about. Like, it's the same basic principle as radar, but radar and sonar are dealing with reflections, and ultrasound is actually dealing with scatter, which is very, very different in terms of how it behaves. So like the thing, if you Google how does ultrasound work, and even if you like read textbooks like I was doing, like they're always aimed at people who are going to be sonographers. So like you need to, if you're a sonographer, you need to understand how to use the device, but you don't actually need to know like the math of what it's doing. Like as long as you have a vague idea of what the basic principles are, you're good. So it turns out the explanation that all of these sources give you is like oversimplified, like too simplified to write a simulator based on. So like what everything tells you is it's based on, you send out a pulse of sound, and you know the speed of sound roughly in the material that you're dealing with, which in humans is like basically the same speed of sound as water, because humans like are most of the physical properties, well, the physical properties of flesh in terms of how it responds to an ultrasound wave is all very similar to the physical properties of water. A little bit different, but the fact that it's all very similar is why ultrasound works at all. So because it's all watery, you know roughly how fast sound moves. So you send out a pulse, and then you listen for pulses on that same frequency. And so a pulse goes out, it hits a thing, like a bone or whatever, and when it hits that thing, it reflects, and can also refract. So it's based on Snell's law, which is some fraction of the energy gets reflected backwards, and some fraction of the energy it continues through, and it may be refracted, but like it's some fraction gets bounced back and some fraction continues on, and that fraction is based on, everything tells you it's the density, but that's not actually, that's an oversimplification. It's more complicated than that.
Oh my god.
But like it's understandable.
So you know what's there because of Snell's law.
So some of it bounces back, and then that, given the speed of sound, takes like some time to go backwards back to the transducer, which sent the pulse and is now listening for the pulse. So you hear the pulse, and then you know it's been in nanoseconds since we sent the pulse out, so we just multiply the time by the speed, and that gives us the distance. And so you know that, oh, we hit a thing and it's this far into the body. And then because only a fraction of the energy bounced back, some of it continues on, and then that can bounce back and give you images of things further in. So there's less and less energy to work with the further it goes into the body. And then all you have to do is just boost the gain further out. It's literally called time gain compensation, and it's just like a knob on an ultrasound machine, which is like, how much do we boost the signal coming from more distant objects? So that's like the dirt simple like textbook version. But if you think about like what an ultrasound looks like an image, it's all grayscale, right? Like there's just gray stuff everywhere. Some of it's bright, some of it's dark. And if you think about what I just described, you're only going to get an image where there's a material with enough of a density difference that it reflects sound back. So like I built a simulator that did this and realized like, oh, it's only going to show me the edges of things. Where you go from one material to another is where there's a difference in density. And that difference in density is the function that controls the Snell's law stuff. So when your wave is passing through a homogeneous material, there's no density difference, because when you're moving from a material to more of the same material, so the density doesn't change, so there's no you're pumping zeros into Snell's law, you get zero reflection. So the only place that reflects is where that density changes very rapidly, like where you go from muscle into bone. Suddenly those numbers change, so suddenly there's a thing that reflects the energy. Does that all make sense, or am I just talking?
I'm essentially guessing that you can only tell what's what because there's a difference in density. You can approximate the difference in density because you can approximate the difference in energy that's scattered versus reflected, right? And
what I'm talking about is only reflection, because this is what all of the textbooks tell you, and this is how sonar works.
Oh, okay.
And it's kind of an oversimplification for radar, but it's also basically how radar works. Like radar is just going to be going through air the whole way, and you don't want to see the air. You just want to see where there's a thing that isn't air, such as a plane. But ultrasound doesn't do that. Ultrasound gives you, like, you see grayscale. You can see like all of these interior details inside of organs and stuff. And I was like, what the fuck? Like, this is none of these descriptions. There's clearly more going on than any of these descriptions I can find, and eventually like did enough research and dug into it and figured out that like, reflection is actually like a very, very minor part of what creates the image in ultrasound. Like, that is going on. There is that Snell's law stuff, but it's a tiny fraction of the energy that you're dealing with. Almost all of the energy is coming from backscatter. And backscatter is like, we were describing scatter, right? The light hits a thing, every photon is spread out randomly, so it becomes diffuse. It makes like a blurry cone. Ultrasound is sound, so it actually is a wave. You don't have the like wave particle duality of light, but in practice, like, it basically behaves exactly the same way because all of our light physics mostly assumes everything's waves anyway. So you get the same like reflection, refraction, absorption, scatter, but where so visible light, as we were talking about, is mostly reflection and absorption, and occasionally refraction. X-ray is almost entirely just absorption. Turns out ultrasound is almost entirely scatter and nothing else.
Is that why it's kind of fuzzy?
No, it's fuzzy because it's an absolutely batshit way to construct an image, and it doesn't work very well. Yeah, I could talk about ultrasound for a really long time, but like everything I just described, like if you take what I described and tried to write an ultrasound simulator, you would immediately find like 1,000 problems, and then you would be like, how do they mitigate those problems? And the answer is they don't. It's just like ultrasound images are mostly artifact, and the reason a sonographer has to be a trained thing and not just like some dude who sticks an ultrasound probe on you and looks at the image is that like distinguishing what is actual data and what is just an artifact of the bizarre way that the ultrasound probe works in the first place is like an incredibly technical skill. Anyway, so it's all scatter, specifically backscatter, meaning like the material scatters so much that there's energy thrown in all directions, and it's like more of it will be scattered roughly in the forward direction, but some of it will still be scattered backwards. And like scattering is not reflection because it's diffuse, right? It's like some weird probabilistic thing of like every energy packet can go in any direction based on some kind of like probability distribution. It's like it gets insane.
And then because you're only rendering at 60 frames per second and not literally the speed of the universe. Okay, in video game you have to approximate scatter.
Yeah, video games all have to approximate scatter. I did it by doing everything in one dimension, which is not worth going into like how the sim works because I have to spend a very long time with actual pictures and stuff to like explain how ultrasound actually works first. But point being, it's almost entirely backscatter, and like the fraction of energy that comes back as the beam passes through a material, it is constantly being scattered. Because like as you might expect, like flesh doesn't really transmit waves all that well. The waves get scattered all over the place. And the fraction of energy that gets backscattered is something like 10 to the negative sixths as a fraction of like the input energy. Like it's an incredibly tiny number. You put a relatively huge wave of energy in, and most of it just goes straight through the body. and like incredibly tiny fraction of it bounces back, and that's actually what the probe is detecting and using to render an image.
That's why it's that's why it's so shitty.
One of the reasons. Yeah.
One of the reasons. Okay.
It's also shitty because of speckle, which is cool as hell. You know how you have you play with a laser pointer, the dot of the laser pointer has that weird sort of like grainy pattern to it.
Mm-hmm.
Like it has this weird sort of like sparkliness around the edges that like your eyes can't really make out, but like it looks weird. That pattern is not noise. That pattern is called speckle, and it's different from noise because speckle is what happens when it's like constructive and destructive interference. You have a wave that is a constant wavelength because a laser emits light that's all one wavelength, and this is so much easier if I can find a picture. 1 second.
My brain is like, my GPU in my brain is running at 100% trying to visualize these images. I don't know I don't know if it's the same for chat right now.
There, I've placed an image in chat. That is what speckle looks like.
Oh yeah, that isn't quite noise. It looks cool.
Yeah, it looks like Perlin noise. Which is interesting because Perlin noise isn't like noisy pixels, right? It's like lumpy.
Mm-hmm.
And what that is the waves are all the same wavelength, because that's what's weird about lasers, right? They only emit like basically one wavelength of light. That light gets scattered when it hits the material. This is one of the situations where scatter on like visible light actually matters.
Do lasers actually only emit one wavelength, or is it like a LED where it's like a spike in wavelength?
Everything is a spike because it's all continuous, right? Like there is no one wavelength. One wavelength would be an infinitely narrow spike, and that's not physically possible.
Okay.
So it's a very, very, very narrow range of wavelengths centered around whatever target wavelength you're dealing with. Narrow enough that for most purposes you can say like a laser emits one wavelength. It's not strictly true, but it's close enough. So you've got one wavelength, it's being scattered, which means it's being sent all different directions. Scattering does not change the amplitude. So you have all of these waves that are all exactly the same. Sorry, it doesn't change the amplitude, and it doesn't change the frequency. So like the distance between like the wavelength stays the same when it's scattered. It changes direction, which means it changes the phase. So it's a shit ton of waves that are all the same frequency and the same amplitude that are all overlapping each other, so they make constructive and destructive interference. So you get this pattern that looks like Perlin noise, because it is noise. It's randomly distributed oscillations, but there's a spatial frequency to it because every wave has the same wavelength. Okay,
so I understand this. I don't know if chat understands this.
Yeah, it's not. I am very interested in these topics, but I don't know how hard.
No, keep going. Keep going.
The point here is it makes a very distinctive pattern.
And you have to be trained to recognize it.
Ultrasound makes the same pattern, because ultrasound is shooting in one specific wavelength. Like the transducer makes one wavelength, and that's integral to how the ultrasound probe works.
Okay.
So when you look at an ultrasound image and it's all noisy, it's not noise. Like it's not like there's random noise in the signal that's getting boosted by gain or whatever. Like that is going on, but like that graininess that you see in ultrasound images is directly tied to the frequency that the probe is firing at. If you increase the frequency, the grain becomes smaller because the wavelength is shorter. And higher wavelength gets absorbed more quickly, so you can't penetrate as deep. So like that is a knob that you play with when you're doing ultrasound stuff, is playing with what the frequency is to trade off depth versus how much you can actually see, because that noise has a scale to it, and you want it to be small so that it doesn't mask details. But yeah, it's the size of the noise is directly related to the frequency, which is like incredibly fascinating, and also nobody explained. I had to just like fucking figure this out.
Can I appreciate that like how difficult that is to like, if I were smart enough, or like not smart enough, knowledgeable enough about this stuff, and have a enough career existential need to do this stuff, I would probably stop at like, yeah, I couldn't get to work. Like I followed all these textbooks and papers about ultrasounds. I couldn't get it to work. I won't go like, wait, it doesn't work. How do I make it work? Like,
yeah. It was a very weird set of circumstances, like at this company, that resulted in like, sure, let's just have our one graphics programmer build an ultrasound sim by himself for a year.
I don't think most people, like most graphics programmers, do that either.
And honestly, like a better managed company would probably have not made the decision. But it was very interesting.
Oh, that is some serious ass determination. That is neat. Someone's reaction. That is neat. That was their first message in chat. It is neat. It's real neat. It just hurts my brain.
And it's very cool that like the noise pattern in ultrasound and that noise that you see around the edge of a laser are the same thing. It also shows up in radar, but I don't know very much about radar. When I started trying to get like really into the weeds on math, like the only resources I could find were talking about radar, but radar it's sufficiently different from ultrasound that I wasn't really able to like transfer the knowledge at all. Like I would have had to spend another year learning how radar works first.
So the noise is really about interference and echoing. No, it's a result of the it's a result of you sending a bunch of rays, and then the rays are not all like being sent directly at the same spot, right? And then either they're being scattered, or because they're just not being sent from the same spot. When you image them, when you pick them up from the other side, or when you pick them up from the other side, because the weights are all slightly different, they're overlapping each other, and they're creating something that looks like noise, because they're kind of fucking with each other right in front of the detector.
Yep,
that's what it is. So that's why it's
you can make it yourself in a shader by just making a bunch of sine waves that are all the same frequency, like spatial frequency, like the distance between the wave tops measured in pixels.
Mm-hmm.
You just make like a shit ton of waves that are all the same frequency but all going different directions and all have different phase offsets, and you'll get that pattern.
Yep. And phase all just means you're sliding the wave like a little bit, like imagine if like your sine wave, like every single one starts at a different point on the wave in time, like so a sonic superposition which reads like a bunch of different signals to the detector. Sonic? I guess sonic is spatial, so it's like.
Well, sonic because it's sound.
Yeah, but like sound exists as sound exists in space, like if you move, so same thing. Yep.
Yeah, you could describe it that way.
Yep. Reads like a bunch of different signals to the detector. Well, the detector reads a bunch of them at the same time, at an instantaneous point in space, and that's what it looks like to the detector.
Yeah, so every row of pixels is tied to a time, meaning so like it sends out the pulse and then it immediately starts listening, and whatever it hears, say like 1 nanosecond, it just writes out as a row of pixels, because it knows that like the distance that the sound could have traveled in that nanosecond is like the distance of 1 pixel. Like, I'm picking numbers that are made up here, but like the first row of pixels is the first thing that it hears. And then it waits another nanosecond or however long it would take for sound to travel 2 pixels. And then whatever it hears at that point, it writes out the second row of pixels. And then it just does that until it runs out of pixels. So the like vertical distance in pixel rows is also the physical distance that the sound traveled. Which is why you don't need a computer to build an ultrasound probe. Like, you can just make it out of circuits. Because like there's no like elaborate math that you have to be doing to get a basic image. Like, all you need is like send a signal out as you receive it.
How would you
That's why
understand...
radar was invented in like 1910 or whatever.
Well, I mean, the invention of radar actually led to a bunch of being able to make computers too as well.
Yeah.
How was you understanding this while understanding this stuff? I feel like you while programming, right? How do you understand this while making the game? I'll be honest. I'm struggling a bit. But and right now the understanding this is higher priority than the game. So whenever you see my screen stop moving, especially if my mouse stops moving, it means I'm sending all my blood to my brain to try to understand this.
Here,
So
I pasted a shader toy that does the like destructive and constructive interference thing. You can, like, click your mouse around in that to like change where the waves are aligning.
Oh yeah, by the way, remember that IQ guy, Nico? He co-created shader toy. very important guy.
Also, this shader toy is Fabrice Neyret. I don't know how you say his name. He's a French dude. But he's like probably my favorite computer guy. Like, everything he works on is fucking incredible. He makes a million shader toy things like this that are just like incredibly cool concepts. He worked at INRIA, which is France's I guess you'd call it the equivalent of like the National Science Foundation, but like they're cooler than us, so they spend way more money on research than we do. And he did a bunch of really cool research into like terrain rendering, like ways, like how do you, for like flight sim type stuff, how would you render like 1 billion trees? And like he came up with the most insane volumetric rendering paper I have ever seen. Like, I think literally no one has ever implemented that paper because it looks incredible, but the technique for it is just like that shit.
The French don't exist, so that's fine. Yeah, the French exist in their own plane. Single pass Gaussian blur? What?
Yeah, you could do it in 1 pass. The only reason to do it in 2 passes is because it's faster.
Oh, is it?
Yeah.
Oh, okay. That's so unintuitive.
Yeah, if it's in 1 pass, like the kernel has to sample every other pixel in the blur radius, which is going to be a square. So if you have like a 9 pixel by 9 pixel blur, that's going to be 9 texture samples times 9 texture samples. So you've got 81 texture samples to do a 9 pixel blur in 1 pass. If you do it in 2 passes, you do 9 pixels horizontally, and then you blur the result of that 9 pixels vertically, so it's 9 plus 9 taps instead of 9 times 9. So 18 instead of 81. So it's just massively faster. The only reason that works is specifically because it's a Gaussian, and it gets into some weird numerical properties of what a Gaussian curve is, and like there's a very narrow category of curves that like can be separated into 2 passes like that. If you're doing like a bokeh blur where you want like those cool hexagons, or if you're doing like a lens flare blur where you want like the like anamorphic like super wide narrow lens flares and stuff, none of those are separable, so you just have to do those in 1 pass, and it's way more expensive.
And I've been meaning to ask this for a while now, but for computers, is multiplying basically just adding a bunch of time together?
Sorry, I was reading chat. What was that question?
For computers, like when you multiply, do computers basically just keep adding stuff to get a multiply number? Is that why it's more expensive, or do they actually do something smarter than just keep adding?
That is a question for a computer engineer.
Oh right, you're a biographic
well,
software
I'm a
engineer.
programmer. I write software that runs on computers. I don't build computers, and like the hardware side of how computers work is like a totally different discipline. Like, I took a class on this in college, and the way we made a multiplier then was stack a shit ton of adders together. But I would assume if you like work at Intel, you might have some more tricks up your sleeve than the one class I took in college.
Oh. Fast multiply exists. It's technically possible to build a multiplier circuit. Yeah, that's what I thought. I definitely don't know anything about that. What's the difference between Gaussian and radial blurs?
Well, radial blur is just like Photoshop's name for a thing that Photoshop does. It's not like a well-defined idea. A Gaussian blur
that's the one that spins, right? The one that spins around.
Yeah.
Okay.
Yeah, the difference between a radial and a Gaussian blur would be open Photoshop and apply a Gaussian blur, and then apply a radial blur instead, and notice that they look like different things. Like they're just doing different. The thing that they do is different, so they're just going to look different. There's not like a smart technical answer I can give to that, unfortunately. Well, we have one person who knows about how actual computers work in chat.
Yeah, like recall thing in design for a multiply circuit that isn't just the adders stacked together. So it is in some ways. Sometimes it is adders stacked together. That's kind of cool. The only reason I thought about this is because I saw a mechanical, like an electromechanical computer video, and it's super.
Oh yeah,
cool. I love those things. You're someone that I imagine one day will buy an electromechanical computer.
What, me?
Yeah, that seems like something you would buy.
Maybe. I do want to buy a Curta calculator. They're like $1,000.
That's a mechanical computer, not
that's
an electromechanical.
That's no electronics at all. It's a bunch of gears that does math.
See. Do you want to talk about industry stuff?
Sure.
Like an IBM. No, an IBM is just a computer company. Do you want to talk about the Blizzard and Bungie acquisitions?
We could. I don't know what there is to say about them other than it's depressing.
Do you want to talk about the stream? Do you want to talk about the stream apocalypse? Why it is depressing?
It's depressing.
Okay, we can. Do you want to talk about your? Do you want to talk about? Do you want to talk about the way you hacked your insulin?
Oh yeah, we could go into that.
Yeah. So Oh yeah, I forgot we didn't show them what the Curta calculator looks like. It's this thing. This mechanical calculator looks extremely cool. You like punch in your numbers and you spin the thing at the top, and then what? Yeah. So what it's like insulin? Is it called an insulin meter? Or is it insulin like a blood sugar?
Insulin pump.
There we go.
So,
pump.
Yeah, so I have type 1 diabetes, which is not the same as type 2 diabetes, which is the one that like everybody in America has. And they're like two different illnesses that don't really have much to do with each other. Type 2 is insulin resistance, and it's like your body produces insulin, which is a hormone that lowers blood glucose. And for whatever reason in type 2, it just doesn't work very well. Like you are resistant to insulin, so the insulin doesn't hit as hard as it's supposed to, and your blood glucose climbs. And it's like super common in America because weight and age are both risk factors for it, and Americans on the whole are old and overweight. So like to be fair, like you can absolutely just be unlucky and get type 2 as like a young healthy person too. It's just that like those two things are risk factors, so it's like super common. So usually when you see news stuff talking about diabetes without specifying a type, they're talking about type 2. Type 1 is what I have, which is an autoimmune thing where your immune system just kills all of the cells in your pancreas that make insulin. So then you just don't have insulin. So then you just have to do manual endocrine system.
Are those cells gone like for good once you have diabetes type 1? Like they can't grow back because there's no parent cells, quote unquote parent cells, right?
Right, and also your immune system doesn't stop killing them.
Yeah.
So there is like research to like do like stem cell stuff to like get some of your like bone cells or whatever and like clone them and get them to make the insulin cells for you, but then like your immune system will just kill them off again, which is very unfortunate. So with that, what I have to do is I have to dose all of my insulin manually and keep track of what my blood glucose is manually, and it's an incredibly complicated task that I have to do like all of the time, because in a normal person it just happens automatically, but everything about the endocrine system is just like unbelievably complicated and not very well understood medically.
You have to do math to do that too? Like you have to like
although I mean it's division, it's not like hard math, but
imagine if you had a CUDA calculator to figure out your insulin doses.
That's one of the reasons I've thought of as a justification for buying one. Is like, what if I use this for all of my stupid blood glucose calculations? It's still not actually worth $1,000.
No way.
But damn, it would be cool.
I mean, you're already paying a bunch for the insulin anyway. Might as well just.
Yeah.
Alright, go on.
So what I have are two pieces of equipment, which are a continuous blood glucose sensor, which is a little electronic thing that's stuck in my arm and has a little electrode under the skin that Bluetooths to my phone and tells me what my blood sugar is. Those didn't exist until like maybe 10 years or so ago, and they were like really shitty for a while, but they're actually like good now. And then I also have an insulin pump, which is a small device that is also, it's connected to a tube that's like stuck under the skin, that carries insulin, and it gives me like a low dosage of insulin all the time. And that's like some of the math I have to do is like you need, assuming you eat regularly, you're always digesting like some food, so your blood glucose is kind of always going up a little bit. So you have like a baseline insulin requirement that you need all the time to keep your blood sugar under control. And then when you eat food, you have to give yourself more insulin to cover the glucose in that food. And that's where the math comes in, is I have to like calculate whatever the dosage needs to be. So I have an insulin pump, which just like it's connected to me all the time, so that gives me the both the like all day low dosage and also like delivers the higher dosage that I calculate when I eat anything. So if blood sugar is too high, you need to give yourself insulin to bring it down. Long-term high blood sugar is like super dangerous. It's like why people with diabetes go blind and like have to get like limbs amputated and shit, because like it just kind of, high blood sugar just kind of like destroys blood vessels and nerve endings, and most of your body is blood vessels and nerve endings.
I only know this word because I try to be emo, but that's called being hyperglycemic, right?
Yes.
Okay, hypo will be the opposite.
Yep.
I knew people that had to check every snack they had during school with one of those glucose meters. That's what you basically have to do, right?
Yep. Okay. Until I got the continuous sensor a few years back, yeah.
So both the sensor and the pump, Do you have to have the pump connected to you all the time, or?
Yep.
And the sensor too?
Yep.
So you basically just have those things like just have 2 needles in you all the time.
Yep.
Oh.
Yeah, the sensor's stuck in my arm. That's not actually a needle. It's just like a very thin little electrode wire, so it doesn't hurt.
Mm-hmm.
The pump is stuck in my stomach, and it's like it's a very short like catheter, sort of like an IV, but smaller. So not comfortable, but it's not like painful either. Those both have to be changed like every few days so they don't get infected and stuff. But yeah, they're just like stuck on me all the time. So if blood glucose is up, you need to give yourself insulin to bring it down. If you give yourself too much insulin, or if your metabolism just says "fuck you," today is an exciting day, your blood sugar goes too low. Low blood glucose is hypoglycemia. Hypoglycemia doesn't really have any like long-term danger that we know about, but it is tired, immediately right? Life-threatening in the short term.
Never mind. Now I was like, but I didn't know. Okay, okay, go on.
Yeah, if your blood sugar goes too low, the thing about glucose is that your brain uses it to like do brain shit.
I mean, the brain's not all that important, right? I mean, you don't need it.
Yeah. So if your blood glucose goes too low, I mean, first thing that happens is you just feel like shit, and like usually that's all I have to deal with. But like if it goes on for too long, you usually pass out and eventually just like have a seizure and die.
That's a lot worse than I was expecting.
Yeah, low blood glucose is bad. The way you deal with low blood glucose is you consume glucose. So you just like drink fruit juice or whatever, like anything with a high glycemic index, or like juice is usually really effective.
This is why good dietitians will tell you like, don't drink juices. You'll get fat really fast.
Yeah. Yeah, that's why I can't diet, because every time I try to eat less food, my blood sugar goes low, and then I have to chug like 3 glasses of cranberry juice and just like I just ate like 3 meals worth of calories in order to not die. It sucks. Oh yeah, this is a total aside. The other really funny thing is, you know how like if you're really, really thirsty, water just tastes like the most incredible thing ever. Yeah. Like your brain's desire for it makes it awesome.
So the sugar
low blood glucose does that to all food. Like, I would not recommend experiencing hypoglycemia, because I would not recommend passing out and having a seizure, but food tastes fucking incredible when your blood glucose is really low.
How do you know you're hypoglycemic though? I mean, up to a certain point where you're like literally dying. Like, how do you know you're hypoglycemic though? Like the only sign I know is that you start shaking, because you're like you start shaking.
Yeah,
from,
that's
like,
one
hunger.
of the symptoms. There's like a bunch of symptoms. What?
Someone said good to know about the food tasting.
Yeah. Yeah. There's like, to use the medical term, there's a constellation of symptoms. Yeah, the shakiness is a big one. Just general like weakness, tiredness. It gets really hard to focus at all. Like you can get like, a lot of people can think you're drunk. Dizziness, headaches, blurry vision, weird visual artifacts, which is not in any of the like medical documentation I've ever seen, but like lots of people with diabetes talk about it. You get like, you know when you like rub your eyes, you see like weird sparkle shapes? You get like that in like a specific pattern, which is really strange.
Really?
Yeah. Where was I going to this? Oh, well, the main thing though is that like it's a distinctive sensation that you learn to recognize that I can't really describe. It's like, how would you describe being thirsty?
That's true.
Like you know what that feeling feels like, and you know that feeling means you're thirsty and you should go drink water. And if you have diabetes, you learn very quickly that like, oh, this is the low blood glucose sensation, and I need to solve this by drinking some juice or whatever.
No, chat, don't induce hypoglycemia before a meal. Body, panic, we're trying to make everything edible. Man, hee, food tastes fucking great. Basically, just starve yourself, but as a diabetic, no, don't do this, don't do this. It'll be hard to do this anyway. Your body has like a lot of mechanism to keep you from intentionally starving yourself when you have food.
Yeah. So all that is like background context to explain why technology is useful, because like I'm just looking at my blood glucose all the time. Like it's on my phone. I actually hooked up like a little Raspberry Pi with a little screen that's like sitting on a shelf that I can just see that just always has my blood glucose on it.
Yeah, so you guys thought he was talking. I called him a biohacker because he was like, he just has these devices that he has to, because of his type 1 diabetes, he has these devices, right? No, he's a biohacker because he hacked these devices. Keep going.
Yeah. So the thing is, like, if your blood sugar's up, you have to give yourself insulin to go down. If your blood sugar's down, you need to like. The pump can't solve that problem right now. There are attempts to like build insulin pumps that can also give you glucose, but there are like problems with that. Like injecting glucose is a great way to get an infection. Anyway, that's an aside. But so like it's a constant balancing act, and most of it's math, and it's all these like annoying like decay curves, because like you give yourself insulin and it takes a certain amount of time before it starts like having any effect, and then it like its effect falls off over time. So like it's actually like an integral, like you're dealing with like areas under curves to figure out like how much the insulin that is currently in your body is still going to lower things and stuff.
Oh my god, you have the Lost Planet like heat meter that goes down over time. I don't know if anyone played Lost Planet, but like, you know, the your character just is freezing basically all the time. And sorry, go on.
So the obvious thing then is like, well, if we have all of the numbers, why do we not have a computer just like deal with this? Why do I have to think about it? And the answer to that is capitalism fucking sucks. Like Medtronic built a system that like semi-automates some of this shit, but like it just sucks garbage ass and forces you to like only use other Medtronic products, which like also suck fucking ass. And like the FDA, like as much as I'm glad they exist, like are also just kind of incompetent at their jobs, and like wouldn't like approve a lot of systems that could do a lot of these things, mostly due to the FDA being terrified of software controlled drug delivery due to the Therac 20 something or other, I forget the number of which, but like there was a radiation therapy in the 80s that like murdered a bunch of people because the software was written wrong, and like because of that the FDA like doesn't want to approve software
the FDA also
medicine.
is the FDA the one that came up with the shitty food pyramid from like the 90s? I think
Maybe?
it was the FDA, right?
Like
So from what I understand, like the FDA doesn't do bad. Like, so if you're wondering about the shitty food pyramid, it's the one that like contributed a ton to obesity, because there was like a massive part. There was just a massive like half of the pyramid was like carbs, and it was like a section with dairy for some reason, right? And people thought, hey, you're supposed to eat this much, you know, and then it turned out no, that's actually a good way to make.
Isn't it also just like a bunch of like corn lobbyists that like made that or something too?
From what I did a little bit more, tiny little bit more reading into it, and like the FDA didn't do it out of malice. Like it wasn't like lobbyists. It was just like the FDA was like, hey, we don't know what to do. We had to come up with something. But we don't know what to. We don't know. We're not experts at food, even though we're called the Food and Drug Administration. And so they asked a bunch of like industry people, and the industry people just happened to be like people that worked in the grain industry and the dairy industry. So it's not lobbyists, it's just like they just, yeah, I guess kind of ways like in a kind of way it's kind of like lobbyists, but like I don't think the FDA made a bad recommendation out of like not knowing what like how to make a food pyramid, not directly because of these companies and malice. I guess you could still make the argument as like directly like malice, but whatever.
Yeah, I mean, as somebody is saying, the FDA's job is to err on the side of caution, and like, yeah, absolutely. Like, I'm not actually. This is not going to be me bad mouthing the FDA stream.
Yeah. It's also there's also the USDA and
me
the FDA.
being anti-capitalist is like I would actually prefer having a government entity that's explicitly in charge of regulating corporations, but like the FDA is itself kind of captured by a lot of those corporations, so it gets really complicated. Anyway, the practical thing is just that like the EU's version of the FDA and like South Korea's version of the FDA have allowed a bunch of automated insulin stuff for like fucking forever. Because apparently, I don't, without even getting into politics of it, like they're apparently just like better at their jobs than our government is.
Korea has some other
anyway.
problems too. We don't have to talk about now. Like it's specifically related to this particular field. We can talk about some other time.
All that to say, people with diabetes were like, fuck this. Like, the reason we can't like make things a whole lot easier for ourselves by automating things is because none of the companies that make these devices will like allow that to happen. And so some people who are not me, I am not actually hacker. I don't actually know how to do these things. I just know how to use things that other people built already. Some guy in like 2013 or so figured out that there was like a massive security vulnerability in a bunch of insulin pumps. You just like some of y'all might have actually like seen that because it was like in the news a bunch that like Medtronic made insulin pumps that had a remote control, like a little like handheld device for operating them. And the point of that was that like if you have the pump, like I have to wear clothes that have pockets so I can carry the pump around. If you're like wearing a dress or like any other just like more complicated clothing, like stowing the pump somewhere gets complicated. So they made this little remote where you can like stick it underneath your clothes and then you can just operate it with the remote, so you don't have to like undress yourself to get to the pump, which is great, brilliant idea. They also put no security of any kind on it. So like the only authentication between the remote and the pump is just the serial number of the pump. So hypothetically, anyone with like a Pringles can radio and the serial number of your pump could just like hijack the pump and give you insulin and kill you.
So it just directly use like random like RF transmission.
Yeah, it's 900 megahertz. So this like was a bunch of just terrible PR for Medtronic, which I think is a little bit unfair because like honestly, like if somebody wanted to murder me, there are a whole lot of way more effective ways to do it than like try to figure out what the serial number of my insulin pump is and then like try to build a radio telescope to control it from like somewhere else.
Unless that guy just happened to really like RC cars.
Well, there's a protocol. Like you can't just like control it accidentally. Like it does have like a handshake where it like validates the serial number and stuff. It's just that like the only security on it is just that like you know a code that's printed on the pump itself.
Oh, okay. So you actually have to know the code. Okay.
Yeah. It's not like from an OPSEC standpoint, it's not secure, but it's not like buggy.
Had anyone ever tried like a war dial like insulin pump codes?
I think you have to approve it on the pump side too. Like it's not the hackers can hack diabetes to death thing was overblown, and that was not really what the security researcher was getting at either. Like, but that was the headlines that we got, that like hackers can hack people to death.
I see what you mean by I see what you mean by the person has to like want to kill you. They have to get the code and then approve the pump. Imagine like in the middle of the night they're like, all right, he's asleep. I'm gonna look at his pump and get the code. I'm gonna press the button to approve the code, and then he's like, I'm gonna wait for the right time to this would have to be somebody that lives with me, and if somebody lives with me, they have a lot of ways to kill me that don't involve the insulin pump. Anyway, all this to say, Medtronic responded to this not by fixing any of the problems, but by just removing this feature from all insulin pumps going forward. Great.
So there are no more insulin pump remotes. which sucks because it was a really useful feature. What people figured out about like 5 years ago at this point. I forgot how time works because we've been in a pandemic for like 2 years. It used to be like
I'm
2
still
or 3
stuck in
years ago.
2019.
What used to be 2 or 3 years ago, some people were like, fuck this with all the FDA stuff we were talking about, and we were like, hey, somebody figured out a way to just control a pump with a radio. Software-defined radios are a thing. You can just plug an SDR board onto a Raspberry Pi, and then you can just like send radio signals to an insulin pump. And then also we have these continuous glucose monitors that are just Bluetooth. And so like the manufacturer of the sensors doesn't really want you to do this. Like, you're supposed to use their app to pair with it, but it's not actually that hard to just write your own app that connects to the Bluetooth transmitter and reads the blood glucose itself. So if you've got blood glucose data coming in and you've got a way to radio control the pump, then you can just like write software that automates insulin delivery. And so this exists. It's called Open APS, where APS is automated pancreas system. And so like I set it up. Like you calls me a hacker for it, which is true because I am hacking my insulin pump, but also like I didn't figure out any of this stuff. Like,
well, you wrote a web interface.
Downloaded a bunch
right?
of code off of GitHub and ran it on a Pi and bought an SDR board and plugged it in there and like hooked it up to a web server and a bunch of stuff.
Well,
like, it's a lot of work.
Well, wait. Was the web server part of the hack, or did you have to make that yourself?
So the web server is a separate thing that there's now kind of like a whole ecosystem of like cool open source software that people have built around diabetes stuff. Because it's such a nerd illness. Like, there's so much data. When the continuous glucose monitors became common, people who had kids with diabetes really wanted a way to monitor their kids' blood glucose remotely. Like, if you're sending kids to school, you would still want to know if their blood sugar is low or something. So people very quickly figured out how to hijack the Bluetooth connection and then upload the numbers to a server that you could just read from wherever, like go to a web page to see the blood glucose.
Are you trying to find a new hobby? Try diabetes type 1.
Yeah.
Such a nerd illness.
So that project exists. That's called Night Scout, and that's like every other like weird thing that anyone
Night
builds
Scout,
just uses
such a
the Night
nerd
Scout
name.
API. It's a good name.
Boy, I'm a nerd. If I got an illness, I sure hope it's diabetes type 1, so that I can have an. I'm gonna knock on wood.
Yeah, you can be like the one other person besides me that like cares about UI design.
Oh yeah.
Because the problem is like all of this stuff is like open source, and it's there's a surprisingly large community for it, but the community isn't that big because there aren't that many people who have type 1 diabetes and are also competent software developers and also know the stack, because the stack is, you have to know Bluetooth shit, and you have to know software-defined radio shit, and you have to know web shit, and you have to know app development. Like, you have to be able to make a phone app that does all of these things, or like work on one of the existing ones that are open source. And so like there are so many components of it that like the number of people who are actually doing the development is fairly small. So as much as I like this stuff, like I'm using it and it's keeping me alive and it like saves me it doesn't make my life easier. Like, I still have to pay as much attention to it as I did before I was using the system, but I get better results in terms of blood glucose control for the same amount of energy.
It directly improved the quality of your life, right? So
yes. So like, as much as I like it and I'm glad it exists, also like the software just sucks ass, man. Like, the one that works the best in terms of functionality runs on a Raspberry Pi, so it doesn't have a user interface. The only way to tell what it's doing is to SSH into it and tail some logs and try to figure out what's happening. I was using that for a few years. And there's another project that's just called Loop, which is annoying because it's like very bad search engine optimization. Like, why'd you just name your project Loop? Loop uses a different algorithm, but actually it's iOS only, and like iOS developers are like care more about user interfaces than most other categories of open source nerds. So Loop actually has a much nicer UI. So I actually switched to iPhone like a few months ago, mostly in order to try Loop. And the UI is way better, but also the algorithm that it uses for making dosage calculations is worse than the old one I was using. So like, I'm like, well, now my blood glucose control is worse than it was, but also the way I interface with the devices that are doing all of this stuff is way better. Wish there was some way to fix this, but I'm not. I don't know that tech stack. Like I don't know how to. I don't know Swift. I don't know this weird shitty hybrid. Like, is it mobile? Is it a native? Is it an app? Like modern mobile tech stacks are just like nightmarish. I make video games. I want to build an automated pancreas system in Unity and build the user interface in Unity with like fucking MGUI. And it'll look fantastic, and it will melt your phone battery into a puddle in about 30 minutes.
You could use Unreal, and it'll only take 2 seconds. But you did write
that's. Oh, keep going.
You did write a pretty cool looking UI though. I remember seeing it. You showed me a while back.
Yeah, I gave up on that project because I have too many other projects. I still have a video game I'm supposed to be making.
That's true.
And then like I also want to like be drawing more, and then I did that for a while, and then I was like, I have to finish this fucking video game.
I've been trying to get him to show me his anime girl drawing, but he won't show me his anime girl drawing. He's too intimidated.
I only made one completed one, and I did show you that one.
Art is never finished, just abandoned.
Yep. No, I have to finish Eura, and then I can draw anime girls.
You just gotta be horny enough. If you're horny enough, you'll just draw them no matter what. Yeah.
I'm trying to think what level of SFW I want to respond to that at. We'll not go there.
Ooh,
it's an awful lot of fucking work to resolve being horny. There are much more efficient ways to deal with that problem.
I think it only works when you're like 12 or something like me. Oh, why is it not working? I don't understand. Why is it not working? Sorry, I've still been trying to code this whole time, and the moment I possess the pawn, it just breaks. Oddly, you know.
Yeah. So I mean that does lead to like there's a lot of like weird stuff to talk about with like cyborg ideas and like transhumanism stuff there, because like we got all this weird stuff like Musk is trying to pretend that he's building brain computer interfaces and all this shit, and it's like there's this weird like people want sci-fi cyborg stuff, but then there's like all of us in real life who are actually doing cyborg shit, which like okay, hacking my insulin pump to automate all of this stuff is like cool as hell, but like the only thing it's doing is like trying to get me back to baseline level of human functionality, and like that's what all other like existing stuff that you would call cyborg stuff is, right? Like that's what all prosthetics and like it's all disability based, because like bodies are shitty, and we try to make them not shitty, and like all of the like money and focus on trying to make bodies not shitty is couched in this weird like Ready Player One ass like nerd Musk shit, instead of like, hey, let's go talk to people who like have prosthetics and like ask them what problems they need solved and then solve those. Let's like talk to the people who are building their own glucose automation systems and like put actual money and software development expertise into that. So like you have a good UI and you have like shit that works and doesn't require
I mean, you can make the argument
jamming
that
a bunch of Raspberry Pis together. And
you could probably just hire a bunch of
weird
people
about it.
directly too if you wanted to. 'Cause, I mean, they already know what they're doing. Like, you don't need any training whatsoever. They already they're. I mean, there's the argument to be made that we're already cyborgs, you know, like with the cell phones and everything as well. You don't have to have something physically attached to you, just emotionally attached to you for you to be a cyborg.
Yeah, it's just weird how much of like, I don't know, I don't have a point that I'm getting towards here, I'm just like thinking aloud. Like, all of the discourse around cyborg stuff feels weird because like, like there's like the cyberpunk idea of like, of it being like this body horror thing, like you're like somehow moving away from humanity by having like a robot arm, and then like, but actually we have people with robot arms already, and they have them because their real arms don't work, and like it would be cool if we just put effort into making their robot arms good.
There are some projects. I mean, they're gonna cost like $1 billion, whatever. But I've seen people do the make some pretty. There's a good intersection of technologies that were I forget the name of the company, but they're working on these myoelectric like arm prostheses, like hand prostheses.
Oh, and, yeah, you sent me some of those a while ago. So those look cool.
Yeah, and I mean, the reason why it works is because I have to explain to chat. The reason why it works is because the reason why hand prostheses work if you have a limb that's amputated from the forearm. If you have the elbow and you have a little bit past the elbow. The reason why that still works for these particular kind of prostheses is because all the muscles that control your fingers are in your forearm actually. So that means that all the nerves are actually connected in the forearm, and then the muscles are in your forearm. That means that for each of your digits, there's a long muscle that goes all the way into your forearm that you can read the electrical impulses off of. So there's this company, I forget the name, that there's a couple companies that are doing this method actually, but this one particular one is they basically just have a bunch of these electrodes in your wrist, and then they use a deep learning system to per user to train the system to recognize what you're trying to do. And because you still have all of the nerves, you just don't have your hand. You basically have the full function of your hand. Like in the demo video for this one that I showed you of this girl that was using it, she was able to do pretty fine control. She had pretty fine control over like her hand. It's pretty cool. And it's actually kind of interesting because like I actually looked up kits you can buy for this stuff because one of my friends, Cayman, you guys might know Cayman, he went to university and did stuff like that as part of his thesis. He did some VR stuff with like with these myoelectric sensors. It turned out you can actually buy like a myoelectric sensor like band for not that expensive, and you can even make your own. I think it's definitely under $1,000. I think it's like a couple $100 for like a band. And then it has like its own API and everything. You can program your own like tools and stuff. So I think that's kind of cool. Like, that's the kind of that's one type of prosthesis that has a pretty good promise, I think.
Yeah, I think like trying to like coordinate my thoughts better here. I think what sticks out is that like people are doing cyberpunk shit themselves, but it's all like on the margins in a weird way, and like culturally not like acceptable. Like I mean, like trans people are like the most obvious one of like talk about like doing your endocrine system manually. Like
just a little back, just to clarify, the endocrine system is the hormone system, right? You're talking about.
Yeah, it's like. Yeah, all the hormones, I guess it is mostly just hormones. All of the like chemicals that regulate how your body does all of its body stuff, mostly thyroid and pancreas, both of which produce like dozens of different substances that affect things in ways that are not very well understood. but like trans folks are cool as hell, and it's like you're stuck with a body that sucks, and you like find a way to like fix it. Like that rules. And they're like everyone hates them. And like not to make a trivial not to like trivialize it, but like you have the same kind of thing with like VTubers and like furries and stuff. Like you have this whole sense that like people want to like be different than what they are. Like bodies suck, and everyone like tries to find some way to like have a body that is different from that is more ideal than what they had originally. And that's like cyberpunk as hell, but it's also like everybody thinks furries are weird and makes fun of them. And
I also
VTubers are still like a weird niche. And it's like, I don't know, I think like the actually cool thing that's happening, like the cool future shit that's going on right now is like people finding ways to like take back control of their own physicality, instead of it just being like whatever busted shit you were born with.
Can we do that? Can we do that? But can we do that? But with the housing market, can we just like can we just take back control? I love that groan. Can we just take back the housing market?
Oh god, yeah. Yeah, and like I said, not to like trivialize any of them, because like what trans people deal with is like really unique. But like I feel there's a like philosophical line between like being trans and hacking your insulin pump because fucking Medtronic won't give you the software you need, and like making a fursuit and making a 3D model and hanging out in VR chat all day and making a VTuber, and like there's all this like use technology to become an idealized version of yourself, or even just a version of yourself that like doesn't have problems that you hate. Like I don't think it's cool that I sort of think it's cool that I have an insulin pump that I hacked to automate a bunch of shit, but like I don't want to actually deal with that. Like I would much rather not have this problem. And so like it's cool that people are doing all of this, but it's also got this weird like cultural, like everybody sort of side eyes at it. Like VR chat is its own whole community and ecosystem, and then like as soon as anyone tries to corporatize it, it's Facebook making like fucking Zoom meetings with these like garbage like me's that just look like nightmares, and it's like, oh, this is what happens when like the capitalists get a hold of the cyborg shit that all of the real people were trying to do themselves.
Yeah, and I mean, to be fair, like a lot of this stuff, like it just outside like the insulin pump stuff is not completely like capitalism fault. Like the furry stuff.
There are
like,
a lot of things going on there.
Yeah, or the VR chat stuff. Like the main pressure is just like people just go, oh, you're gonna do weird stuff with it, you know? you're gonna yiff. That's disgusting. What if you get cum on those fursuits? How are you gonna wash it? Yeah, anyway. A metaverse. Yeah, fuck. Yeah, the marketing tech. We can talk about marketing tech again if we feel like, but.
Then I will just get depressed. At least the cyborg stuff has like a note of hope to it, because it feels like people like doing the best they can for themselves under increasingly shitty circumstances.
It just, I guess it comes down to how people depicted like cyborg stuff, right? Like you can only think you can only really think about the like ways in which like people just pick cyborg stuff in like Neuromancer or like other types of fiction where it's always like dystopic, or it's either dystopic or like Ready Player One, where it's like, it's for nerds, it's a nerd paradise. What do you mean I don't have to wear my glasses anymore because I'm a warlock, I'm an orc inside my VR. It's so nerdy and hip. Sorry.
Yeah.
Whereas what you're saying, people should just be thinking of it as like, yeah, I'm a normal human again, or like I'm a slightly better human because I got like this cool arm, or like my eyes are, you know, I have eyes that function normally. I just want to be normal, like, you know.
And it would be fucking cool if instead of all of the technology that all the like biomedical technology that we have, existing to like help people with disabilities, it would be fucking great if we could like improve things, but we're not at that level yet. Like I don't like everybody dies of heart disease because hearts just kind of don't last all that long, and it'd be fucking cool if we could like solve that problem. But
there's a little hope, there's the upside of hope for that particular thing related to the heart. Interestingly enough, the heart is one of the most, in terms of organ transplants, heart transplants are actually one of the most successful ones, because for some reason the heart doesn't reject tissue as well as as much as a lot of the other organs do. Maybe it's because everything that goes in your heart is probably already sterile, so there's your body is not used to having to fight infections in your heart as much. Maybe, I'm not sure. But doctors have mentioned that it's actually one of the most successful transplant surgeries that exist right now. So so for heart, probably as long as we can for heart surgery, I think it's heart surgery, heart transplant and heart replacement, I think it's probably gonna be one of the first organs that we're gonna have perfect replacements for, just because of that. And the other, and so basically once you, if rejection is not as much of an issue with heart transplant, then the only really problem with the heart is that is other complications from having heart surgery, right? So or
those are big.
Yeah, they're big, but I don't think those are insurmountable. I
mean, they are, because you got to physically get in there. Do you want to talk about more medical stuff in heart specifically? Because this is another one of these topics that I fucking know way the fuck too much about because of my weird ass job.
But before we continue, I do want to tell chat that you worked on a heart surgery sim, right? Specifically.
Yeah. Technically not surgery. It's percutaneous coronary intervention, or PCI, which is putting stents and shit in. And it's, terminology wise, it is not surgery, because the point of it is that you do it without cutting somebody's chest open. Is an operation to fix heart problems as minimally invasively as possible. But it's basically heart surgery.
I love that. I was so you worked on heart surgery sim, and someone just in chat was what? Does he make games, or does he train surgeons? Why not both? Why not both?
So we made a game about this PCI procedure, and so now I know way too much about it. And that was one of the things that the weird thing about really seriously learning how medical procedures work is it really gets rid of the idea. It gave me a ton of appreciation for what surgeons do and where medical science is at, but it also dispelled any idea I had about medical technology being super advanced, and the idea that we're going to have a future where we can just replace people's hearts or whatever. We're no fucking where near having replaceable heart. The surgery that we do is still very barbaric almost. It's done very well. It's very it's impressive that we're able to do this shit at all, but what you need to do a any kind of heart surgery, let alone a transplant, is the heart is dead center of the chest. I know we were talking about this, but for chat's edification, you know how everybody tells you the heart is on the left side of your chest, under your left pec? That's not where your heart is. That's
just because of your. Is that just because of the location of the ventricle?
I think it's because that's where a doctor puts a stethoscope to listen to the heart. The heart is dead center of your chest. It's right underneath the sternum, and you can't really put the stethoscope on the sternum, so you got to put it somewhere else. But the left and right sides of your upper chest are the lungs, and the heart is just in between them. Between it's dead center between the spine and the sternum. It's just in that space.
I actually don't think it's the doctor's fault, because doctors actually don't just put the stethoscope there when they're listening to a heart. They put it all over the place. You try to.
Yeah. No, I wasn't blaming doctors. I was saying I think that's that's the reason that people got the idea that that's where your heart
okay.
is. Like,
I was just looking for someone to blame. I was just looking for someone to blame. So I'm gonna blame. I'm
no,
gonna blame people.
If you want to blame someone, blame school teachers.
Oh, okay. Oh, always valid, especially math teachers. Love you, math teachers. I know you're
Yes,
doing your
somehow
best.
this
But
is math
fuck!
teachers' fault.
Yeah. It's your fault that I think the heart is on the left side of the body.
It is like lopsided. Like, it's not a symmetrical organ, and it does lean leftwards. So like, the center of gravity, I guess, is off to the left a little bit, but it's not like under your left pec the way everybody thinks it is. Where the fuck was I going with this?
Surgery.
Oh, surgery. Yeah. So to get to the heart, the sternum's in the way. Like, the heart is directly underneath the rib cage, dead center of your body. So if you want to do surgery on the heart, you saw the fucking sternum in half, and then you put like basically just like a vise in the middle and literally like bend the rib cage apart to make a gap that you can reach through. Like bend the rib bones like at the joint where they hit the spine. You like fold the chest open.
Who needs a rib cage anyway? Rib cage is overrated.
So like, I saw videos of that surgery, and like, as I'm watching this, I'm like, oh fuck, like, how that just ruins your body forever. Like, you don't really heal from that, right? Like,
does breathing hurt after that? Breathing has to hurt.
Oh yeah, you are fucked for months. So like, they do whatever heart surgery they need to do, and like, they save your life. Like, it's worth doing. It's not like doctors are just going in there to ruin your body to be assholes. Like, if you're going to die, you would rather have your ribs fucked up than dying. But yeah, so they saw you open, split your ribs apart, do whatever they need to do on the surgery, and then they just like bend the ribs back into place and staple the sternum back together.
Did you really just staple back together? Did you just like tuck? Oh wow. So did staple just stay in
those
you?
never come out either.
Oh okay.
So like, you'll just have metal staples in your sternum for the rest of your life.
Did that like trigger TSA? That'd be kind of interesting if it does. Like trigger metal detectors. I guess not really.
No,
not enough metal.
It's not that much metal.
I don't
think even pacemakers do. So yeah, you can't breathe. Like, breathing is just excruciatingly painful for like months. You can't like sit up or move because like, your ribs are supposed to be stuck together, and now they're just like not anymore. So yeah, like, seeing stuff like that just always like really like changed my perspective on medicine. That like, oh, like, we think of like a lot of interventions that medicine can do as like fixing a problem, and they do fix a problem, but like, there's a cost to it. There are not a lot of procedures that like aren't going to fuck up the rest of your life in some way. Like, surgery is serious. Even PCI, which is the procedure we were dealing with. PCI is for since I didn't explain what that is. PCI is when you have the arteries in your heart that are clogged by plaque or whatever goop is in there. The way, like, that restricts blood flow to the heart, and that will lead to a heart attack that'll just kill you. So you gotta clean it out somehow. And the way that's usually done is thread. You make an incision, usually in like the elbow, like in those veins, or in the groin, and you thread a catheter. So a catheter is like a rubber tube that's very narrow, but it's hollow through the center. Oh, I'm sorry, I'm getting the steps in the wrong order. You thread a wire.
Wait, pause for a second. Someone said the law of equivalent exchange. Not quite true.
Yes.
Not quite true, because in Fullmetal Alchemist, he traded his brother, like, his brother's body. But in this case, you can't pick what to trade. So it's the law of specific exchange. Not the law of equivalent exchange. You can't just be like, hey, here's my
somebody had to die to give you the heart for the heart transplant, right?
That's true.
That feels
That's
equivalent.
true. But okay, that's true.
But they don't get like vaporized in like cool alchemy runes. Unfortunately, they probably just got hit by a car or something. It's nowhere near as cool.
That's true. It's okay. They're in a better world now, a better fantasy world. Go on. Wire.
So you make an incision like in one of the extremities to get access to a vein, or an artery rather. I spent like years on this and I still never actually can keep track of which one's a vein and which one's an artery. One of those two. You run a wire, which is literally just like a thin flexible wire, where the tip is a little bit curved. You thread that wire all the way up the blood vessel until you get to the heart. And the way you can tell what you're doing here is this is all done under X-ray, which is why I had to build an X-ray sim so that we could make this game.
Yes, I think the thing of having to create the whole universe before you can do the thing you want to do.
Yeah. So you're looking at the heart through an X-ray machine, which is a C-arm. So like you have the X-ray emitter on one side and you have the detector plate on the other side, and this big like C-shaped arc that's like 6 feet across. And so the detector is behind the patient and the emitter is pointed through them. And unlike other X-ray systems, this thing is called a fluoroscope, and a fluoroscope is just a video X-ray. So like the sensor is always recording. So you're actually watching like a live video X-ray instead of just taking a picture. So you're looking at the heart through this X-ray, and then you thread a wire all the way up there until it gets to the heart.
That's gotta be like a whole magnitude greater amount of like potential cancer risk than like a normal X-ray.
Yeah, it's still they do a ton of very impressive work to keep the dosage like absurdly low. A lot of like very interesting like image processing stuff to like deal with all of the noise you get from like using a much lower energy signal. And it's still pulsed. It's not actually like a continuous exposure. It's like 30 FPS or whatever, but it's not actually exposing constantly. It just does a pulse for like a few milliseconds to give you one frame. It's pretty neat.
That is neat.
I actually got to like go watch one of these done because like one of the hospitals in Chicago does like teaching stuff, and like our company has like a relationship with a bunch of the doctors there, so like I actually got to like go watch them do this procedure and like see.
Do doctors like it? Do doctors like it when you have just like a bunch of random game devs like just hanging out watching you?
Doctors are nerds, so like a lot of them do actually like enjoy explaining all of their nerddom to us.
Mm-hmm.
Some of them are just like grumpy old weirdos, but a lot of them are extremely smart technical people who like talking forever about technical topics.
I imagine the radiologists especially are nerdy because they get to like hang out.
Oh, radiologists are fucking cool. I have not got to hang out with any of those. I've been like on the Reddit like radiology subreddit for like years before I even had this job, just because it's like the coolest discipline, and it's also like it's the only good part of Reddit.
I think like from what I understand, like radiology is like one of the few doctor professions you have where like if you're an introvert, you're just like fuck yeah, I get to
you don't deal with patients. You sit in a dark room in front of a computer screen. But yeah, you thread this wire up there, and you can see the wire because it's metal, so it's very dark on the X-ray. And then once the wire is in place at like the start of the when they talk about like plaque in your arteries, they're talking about the arteries that are on the surface of the heart that supply the heart muscle with blood. That's why your arteries being blocked gives you a heart attack, because the actual heart muscle stops getting blood, so it stops beating and then you die. So like that's the part of the body that we're dealing with here, is the blood vessels on the surface of the heart. So you get your wire up there, to get it in the right place to the vessel that you're interested in. And then you thread a catheter around the wire from the groin or the elbow or wherever you made this incision all the way up to the heart. So you get the catheter to the base of the vessel that you're interested in, and then you pull the wire out. So then what you have...
that is quite a bit of so I imagine if you actually that it makes more sense for it to be on like a vein, right, not an artery, because if you cut into an artery, the complication of accidentally causing a really massive hemorrhaging is very high, isn't it?
So arteries are the ones that get clogged up. So ultimately you're aiming for an artery, but the route you get through it is right at the osseum, I think is the word, the opening, where the heart does all of its shit. So everything is interconnected in this giant massive highway interchange kind of thing going on. So you can kind of get from one side to the other once you're there.
Osmosis Jones taught me this. Go on.
And it is arteries because veins have valves.
Oh wait, they have valves? Really?
Yes.
That's how you don't bleed out when you get cut in veins, and you do bleed out because cut in arteries. Is that why it is, or that's just because of a volume issue?
No, that's just that. I think that's actually just a urban legend. You have veins and arteries, and they're running alongside each other. If you cut the aorta or something, or the jugular, those, you die from those, but just because those are fucking huge vessels that move an insane amount of blood, so you die of blood loss.
I guess that makes sense. Otherwise, people won't be able to
be
lose
wrong,
arms.
But I think you have a vein and an artery right next to each other in your arm.
Oh, really?
The name vein or artery just implies which direction the blood is flowing, whether it's going out from the heart or back from the muscle to the heart.
Oh, I didn't know that. I learned something. I learned many new things today, but that's the one another.
Yeah, and like I said, I can never remember which one is which, but yeah, it's just which direction they are. Also, they aren't blue. One of them is always drawn as blue. Deoxygenated blood is not fucking blue. I do not know where we ever got this stupid urban legend from. Well, actually, I do know, and it's complicated optic shit because it looks blue under your skin because of subsurface scattering, which is really fucking fascinating. But
yeah,
God,
it's not blue. It's purple. I'm kidding.
Yeah, it's a very dark red, and the color that you see when you bleed a lot is the color that it is. It's not the urban legend is that it's blue, and then as soon as it's exposed to the air, it oxygenates and turns red, so you never actually get to see it blue. But that's obviously false, because if you've ever gotten blood drawn, they just suck it right into a tube and it's never exposed to air, and it's still just dark red. Deoxygenated blood is slightly darker red than oxygenated, but it's not blue.
I mean, medical students aren't colorists, so they need very clear colors to be able to tell us what, right?
Yeah. God, I'm getting sidetracked so many different ways. I guess this is why you brought me onto this chat, is to just talk about all of this shit while you're...
Oh no, it's super interesting. That's and I sidetrack a little bit sometimes just because I think it wouldn't be as engaging if I just let you run a lecture.
Yeah,
The whole
totally.
time. I like it's super engaging to me. It's and I want to, and this is how I show my engagement, right? Because
yeah. I'm trying to figure out how much I should be restraining myself and how much I should just be talking forever about.
Oh no, don't worry about it. If you're talking too much about it, I'll force you to change topics.
Okay. So you thread a catheter up around the wire, and then you pull the wire out. So now what you have is a tube. The tube comes out of the patient's arm or groin. It's out, all the way out. You can access the end of it. And so one end is accessible to the doctor, and the other end is in the heart at the opening of the blood vessel that you're interested in. So now you have a portal, essentially, right? You just have a tube that runs to the place you're interested in, and you can shove shit into that tube.
Mm-hmm. So you've essentially used a wire. You use a wire. Let me just summarize what you did just now. You use a wire with a curved end. you know, a dull curve then, so you don't end up accidentally like stabbing a patient from the inside.
Yes.
You on there's a little hook on like one end on. There's
So
a way for you.
the curve is there so that you can steer it. You twist the wire like with your hands to change what direction it's pointing to control what vessel it goes into.
And I'm assuming there's it's like a little thing where it's also pulling a tube along with it, right? Like when you.
No, it's just a wire by itself.
Oh wait, so how do you get the tube in again? Like.
Once the wire is in place, you thread the tube over the wire.
Oh, okay, yes. So a doctor is like has like these degrees of motion. He's like he can push, he can pull the wire. He has a tiny little hole in like the person's like elbow or groin, and he has to go for the heart. And he can push and pull, and he can rotate to steer the wire.
Yep.
And he had to get to the heart through a highway network system this way.
Yeah. Although it is like all the forks go out from the heart and you're going the opposite direction, so like getting to the heart is fairly easy because like if you just push, you'll end up there eventually. It's very hard to go down the wrong tube, which is fortunate because like the fluoroscope's only pointed at the heart. It's not pointed at the rest of the body. So
so they're doing this blind.
Yeah, you'd gotta just like shove the wire in there until the end of it shows up on the scope.
Yeah, they said they're just doing this with the hands. It's super fascinating.
Yeah, it's like incredible dexterity. Because like we haven't even gotten to the part where they do the hard stuff. So then you thread the tube down there and pull the wire out, and now you have a tunnel that just goes to the heart. So now you do the actual procedure, which is you're trying to deal with the plaque, and there are a few different things that you can do, but like the primary thing is a stent. And a stent is a little short length of wire that's
one second.
Shape.
Yume, thanks for the raid. Did you have a nice stream?
Oh, that's a bunch of people.
Yeah, thank you. Did you have a nice stream? Did you sing? You sing every time. I always feel sad when I miss you singing. Anyways, you can continue. We're talking where I'm talking with the amazing Do about medical science and graphics programming and X-rays, and my brain is melting. If I hope it's very obvious that my brain is melting because my rate of speech is slowing down. Oh, okay. So what part of the procedure were we at again? With the stent? Oh, you're explaining the stent.
Yeah, so you've got a tube that leads straight to the blood vessel on the heart, and this blood vessel has goop inside of it that's obstructing it. So a stent is a tube that's like a centimeter long. Like you can get different lengths, but like it's like a centimeter long or so, and it's made of like a wire mesh.
This is the one that expands out, right?
Yes, it's like spring loaded and expands outwards. So you slide a new wire down the catheter, and then you like on the fluoroscope do the like wire twisty thing to like guide the wire down the vessel that you care about and get it to the part that has the plaque on it. Oh god, yeah, and like the way you see this is that you like flush like a radio opaque dye through the blood vessels, because like blood vessels don't really show up on X-ray because like they're just flesh. They're not really dense enough to see. So like you flush dye through it out of the catheter, and it makes this like swirling like fluid that like you can see like shoot through the veins, and that's how you also need to do that
for like for other stuff, right? Like for ultrasound. Yep. Don't you also have to drink like put something in your blood vessels if you're checking the blood? I remember.
Yeah, there are a lot of contrast enhanced procedures. There are some CTs that use it too.
I remember having to drink some bitter fluid when I like injured when I fell off a railing and then fell on the railing and I injured my pancreas. I remember I had to like drink something to like to increase the contrast of my organs or something.
Yeah, barium, I think.
Oh, that's what it is? I drank barium? That sounds awesome.
I think so. I would have to look that up, but I think so. But yeah, so like that's all happening, and then like so you thread a wire to the part that has plaque, and hopefully you can just slide it past the plaque, like it's not like totally occluded. And then you slide the stent, which is like on the end of another catheter. So like you have a wire, and then you have a catheter around that has the stent on it, and then this is inside a much bigger catheter, which is the one you use as your like port to get to the place. Like it's all tubes inside of tubes. I didn't do this, but like the other devs had to like build this whole like system for like sticking things inside of other things. Like you have a wire that's inside of a catheter that's inside of a different catheter, but you might be able to like
let me explain that I understand this. So let me explain that let me explain the significance of sticking things inside soft things inside other soft things inside video games. So so every time you have a simulation like a cloud sim or any kind of soft body sim, like usually video games try to avoid any problems with it by only simulating one thing on top of something else and never having anything simulating on top of that. The moment you have stacking levels of like soft body simulations, it becomes incredibly difficult for it to not explode. So this is why we said we had an entire team of guys that just did this. That because like it's like an invisible layer, like invisible couple months of effort just to get that to be stable. Just so you know.
Yeah, this wasn't even actually a physics sim. It was like just a set of rules.
Yeah.
But even just the rules are really complicated because it's like, okay, this wire, you're at a fork in the vessel. The wire can go left or right, unless the wire is inside of a tube, because that tube might already be down the left or right side, and you can't like leave the tube to go right. So like every step along this like tree of vessels, you have to be tracking what things are inside of which things in order to determine what ways they can move. It's wild. Anyway, you thread the stent up there, and then you expand the stent, and it literally just like smashes the plaque against the walls of the vessel. Like it just goes. And you're done. That's the procedure. You pull all the shit out, and you're like, "Yep, your life's saved. We squished all of the goop into the side of your blood vessels. Now you're not going to have a heart attack."
I forget. Does that goop ever like go away? It does gradually go away over time, right?
And this is why I started talking about this, because I was like, this stuff, like these solutions are not permanent. Like, what's the life expectancy after this? Like, if you have
I didn't mean to stent. I mean like cholesterol does eventually go away but it. Right.
The plaque doesn't. It's just there forever.
Oh, okay. I didn't know that. Oh, oof.
If you lower your cholesterol levels, you like produce less plaque, I think, but the stuff that's there never really goes away.
Oh my god. I have to be careful with the amount of eggs I'm eating. Goop is forever. Yeah. That's a very funny way of describing it. Goop is forever.
Yeah, and it's just like smashed into the walls. Like you didn't even get rid of it. Like you just squished it. And apparently this is just how they do this. And like it actually, like, as far as procedures go, it's very minimally invasive. Like it's pretty much outpatient. Like you're not even like what?
Yeah, there's only like a 1 centimeter incision or something in your vein or something, right?
You're not even like actually fully anesthetized. Like they give you enough drugs that you're kind of loopy, like you're out of it, but you still have to be able to like roll over when they need you to move certain ways and stuff. So like they have to be able to talk to you. It's fucking weird.
Oh man, it's like you fucking doing water cooling on a computer. Yeah, there's some water stuck in there. I gotta rotate. I gotta like shake the case a little bit. Hey, can you like stand up and like jump? Do like a jumping jack for me a little bit. My little wire is like stuck in your in your like penis or something.
This is also makes it doubly weird when like I went there to watch it, because it's just like me like with my like long ass nerd hair and like a t-shirt, and where I'm just like in this operating room, and they're like the guy's awake, like he knows I'm there. It's very weird. But yeah, like there are a million other things that can happen in that procedure, and like there are other tools you can use. It's a very dynamic situation. Like you don't really know what's going on until you start the procedure, and then like maybe the plaque is too stiff to be squished correctly, so then you need to like there's a drill, like literally a fucking drill you can use to like grind it up, and then there's like a vacuum hose you can use to try and like suck it up, and there's like all these like absolutely wild tools.
Yeah, it's
There's
you
like
know
little
some
balloons that you can use to like try to squash the plaque just by itself,
and, you know
to like make some room.
sometimes you might run into guilt. You know, you might have to take a laser and zap the guilt. I don't know if you play Trauma Center.
I am aware of it. I haven't actually played it. But yeah, and it was just wild, like learning all of that and like making a game that's about it and simulating it and being like, this shit, like, it's simultaneously like incredibly advanced, but is also like making me realize like we're nowhere near like sci-fi immortality levels. Like we've got guys just like twisting wires around with their fingers in order to like shove goop to the side, and like the goop doesn't go away. Like it solves the problem for probably like 10 years or so, and since you're probably like 70 when you're getting this procedure done, 10 years is fine. The problem might come back and then you have to go get the procedure again. So like sometimes you get patients in and like there's already like just stents everywhere, like their whole blood vessels are just like made of, or just like lined with metal already because you just did this so many times already. And it's just wild. Like this shit is incredibly cool, and it's amazing that like we can actually save people's lives this way. But it's also like this also feels like Dark Ages shit at the same time that it feels hyper advanced. Like we have this incredible X-ray machine that costs like millions of dollars, and it has like giant like 50-inch touch screens everywhere that have all these like multiple displays and like all of this like crazy technology, and like it's so advanced that it's like an outpatient procedure, but it's also like a guy shoves a wire into your crotch and then like twists it around and like blows in a little balloon. At least that's done with a machine and not his mouth, but like it's so manual and so like jank. Like it's
I also don't know if chat realizes this, but outpatient. If you haven't gone to hospital very often, outpatient just means you don't stay in the hospital. That's all it means.
Yeah, you just go home afterwards.
Yep, that's all it means. I mean, it feels advanced because it's better than what it was before, right? And I'm sure,
yeah, like I have all this respect for it.
I'm sure back in the medieval days, when people were like, "Wow, you can pull out teeth with this metal thing instead of using my bare fingers." What an advancement.
The one we were just working on is not a game, it's like a training thing for a client, like medical device company. But we had to do cataract surgery, which is when the lens in your eye becomes opaque, which is just a thing that kind of happens when you age.
Do you know what causes that? Do you know what causes that?
Bodies being shitty.
Oh, well, I mean that explains a bunch of things, but
I don't think there is a known cause. It's just like, yeah, the lens, like the tissue in the lens just kind of doesn't last all that long. So yeah, it becomes opaque, and like so I had to learn how eye surgery works for cataracts, and like to spare everyone the gory details, like this is the one, like I have a strong stomach for medical stuff after doing this for like 6 years at this point, maybe 5 years. But like the eyeball stuff was like a new level of, oh shit, they're just like they're cutting holes in eyeballs.
Dead Space 2 eyeball scene.
Seen the screenshot of that, but have not played it.
So my eyes are really sensitive. Actually, just talking about this stuff is making my eyes water. Like I can't cut onions. I can't cut onions.
I will spare you the details on that, but it's another one that's like, oh, this is incredibly cool. Like it's this immensely like dexterity based procedure, and the guys that can do it are like godlike at it. Like the procedure isn't mechanically very complicated, like the number of steps isn't very large, but like the actual like actions that they have to do with their hands are just like immensely complicated and subtle, and if you fuck it up you like ruin somebody's eye, and if you do it right you like solve their problem. But even then, solving the problem is they're going blind, because they have cataracts, so like their lens doesn't work anymore. So the procedure is to remove it and replace it with an artificial lens. But the artificial lens sucks. Like, on the one hand, it's like incredibly cool that we can just fix blindness, right? Like, this person's going blind and we can like do surgery on their eye so they can see again. But at the same time, like an artificial lens is fixed focus for.
Oh wait, so you can't even. Oh, I didn't know it was fixed. I guess it makes sense because you can't like the way your lens focuses, like it becomes thicker and thinner.
Yep, and like too much of the structure that like controls the shape of the lens is destroyed in the process of removing the lens. So like you can't put in an artificial one and have it like have your eye be able to control it like the old one could.
Oh right, because the control comes from the lens itself doesn't actually have any muscles in it. It's just the muscles around it that push it, that squish it, right?
Yes, the zonules of Zin.
The zonules, are they actually called the zonules of Zin?
They are literally called the zonules of Zin. I am going
the zonules of Zin,
the
really?
Wikipedia article for zonules of Zin in chat.
The zonules of Zin. They must have named that like back when people. Oh, what the fuck happened here? Sorry. They must have named that like back before people, like back when people were like, you know, like medical science was new and the ego was a little bit more strong.
This guy like figured out all of the eye shit. He was like the first person to like take an eye apart and like understand how it worked. So he Zin
was he some like Persian like time period guy or something?
I think it was like 1800s.
Oh, that's way newer. That's too late to be calling this shit fucking zonules.
Medicine hasn't been around very long. Half this shit wasn't discovered until like less than 100 years ago.
Okay, should be modern medicine because I'm pretty sure shitty ancient medicine's been around for a while.
There was from the Wikipedia articles about cataract surgery, we did actually like remove cataract lenses like ages and ages ago, which had to be like a fucking horrific procedure when you like haven't invented anesthetics yet.
Wait, so yeah, why would you want to remove cataracts?
So the lens is like right in the front of the eye, and it's the thing that like focuses the light onto the back of the eye so you can see. Like eye anatomy is complicated if you haven't like looked at it before. I think it's like not what a lot of people think it is. But yeah, the lens is like right at the front of the eye, behind the cornea and behind a bunch of other stuff, but it's not like in the middle of the eyeball, it's near the front. And a cataract is when the lens itself becomes opaque. It just grows like sort of crystalline like shit inside of it that blocks light. So now you're blind because instead of a lens that focuses light, you just have like a black thing in the front of your eye.
Okay.
Entirely blind is worse than unable to focus. So if you just fucking take that shit out, the retina still works. So like you can still see light, you just can't focus. So your vision is going to be absolute trash, because you literally don't have a lens anymore, but you can at least like see patterns of light and dark, right? Like you could tell if maybe like if a person is standing in front of you or something. Like you'd be able to like walk around maybe. So taking the cataract out would actually be like a significant quality of life improvement if it was bad enough. But yeah, the modern version is you take it out in a way that like doesn't traumatize the rest of the eye and doesn't result in infections. And then you put an artificial lens in it, and the artificial lens, as far as I know, like the best ones are like bifocals. Like they have multiple focal lengths, but they're in like, do you know how like bifocal glasses work?
Yeah.
They're like shitty. Like the bottom part is for close-up vision and the upper part is for far away, so you have to like angle your head goofy in order to like look at your phone.
Yeah.
They're like that, but like built into your fucking eye. and like those are the nice ones, and the less fancy ones are just a single distance, so like it focuses at infinity. And so if you want to read anything close up, you just wear reading glasses. But also, most likely, this is only in one eye. So like one of your eyes can focus and the other one can't. Anyway, all that to say, this is harking back to what I was talking about. Of like, it's like it's so impressive that we can do this shit, but like learning about it destroyed all of my like sci-fi beliefs about how advanced medicine is. Like, medicine is nowhere near solving these problems. We can do some really impressive stuff, but the scope of things that can go wrong is so terrifyingly vast.
Really, the solution to solving all these problems is to just give up on biological bodies completely. Everyone just becomes a VTuber. Easy.
Become computer.
You know, I think I do think that we'll end up in a situation where we'll solve how to simulate a brain before we figure out how a brain works. I think
I can imagine that.
I think that's gonna happen like before. I think that's gonna happen before we figure out how to like just fix bodies, and then at that point it's just like, well, do we want to simulate people and just fix everything, but make them like digital from now on? Do we want to like actually, I don't know.
Yeah, I feel like that being. I could imagine that being technically feasible at some point, but it's like so far in the future that I can't really, like, it's not our lifetimes.
Oh my god, I have made almost no progress in my programming, but I managed to make this cannonball work. Sorry, just a little note. And the camera follows it. Oh.
I do really appreciate the 13 Sentinels concept of like, do you die if you upload your brain to the computer? So like, for chat, this is not a spoiler, but also play 13 Sentinels. It's so good.
Yes, please play 13 Sentinels. It is it is probably the most well designed. How do I describe this? Has the best narrative design out of any video game I have ever played. like the best narrative design, not necessarily the best narrative, but the best narrative design. Like, yeah. It's amazing. Like, I'm still thinking about it. I played it March of like 2 years ago, or 1 or 2 years ago, and I'm still thinking about it.
Yeah,
that game
but
is
like a non-spoiler thing about it is like one really cool concept in it is they never say this outright. You just recognize it from like seeing the way characters act. That like the question of do you die when you upload your brain to the computer is 100% yes. Like if you become digitized, you fucking died, and the digital version of you is a different person who is maybe very similar, but like continuity was broken. This is a different guy. But once that's happened once, it doesn't matter anymore. If you're a digital person, then you can like download yourself into like 20 different robot bodies, or just like copy your brain onto a flash drive and have somebody carry it over to a different computer, and like you do not care. Once you have crossed the threshold of like being killed by being digitized, now you just don't care about it anymore. It's no longer a concern for you.
We're gonna end up in a situation where hold on, my brain is melting. I'm trying to move these nodes at the same time while I'm trying to make a sentence. Yeah, we're gonna end up in a situation where we're gonna figure out how to do that first before we figure out human rights for digital humans. So we're gonna end up in a situation where we have fucking like porn stars that just get re-uploaded into like sex toys before we figure out like before someone goes like, oh yeah, we probably shouldn't do that.
Yeah, I hope that doesn't happen, but yeah, probably.
It's probably gonna happen, or they're gonna do something.
I mean, the hope is that actually we just can't do that, and we're just like fundamentally overestimating our own understanding of these things, which I think is also probably true. Like, neuroscience is like so far from understanding anything.
And yeah, that reminds me.
Ask anyone who has to take brain drugs whether we know how brains work.
That reminds me. My writer just came back to me with a background for character design that I haven't unveiled yet for Mahou arms. Do you want me to just tell you it? It's not really a spoiler, so I can tell you it. Like, came over back. So it's for the robot girl. So the idea is that there is this Japanese religious cult that was trying to in the world, right? You kind of scientifically realize that there's like, you kind of scientifically start detecting souls and stuff, right? That's part of the universe. And so a Japanese religious cult, like who has some strong beliefs about like, oh no, it can't, like you only they believe that only like real humans or whatever can have souls, right? So they went around and did some experiments and tried to create an artificial intelligence to disprove that any neural network sufficiently complicated can house a soul that can only be humans. And in doing so, they accidentally created AI and an AI that has a soul. And that, and then they tried, and then they're like, oh,
whoops.
So that's her backstory. And then they were like,
that's
and then
great.
like, yeah, so like they asked, and then of course they try to destroy her because they're a religious cult. And then end up not being able to destroy her, and then she builds herself a body. And starts doing all, and then at this point she's still like a primitive intelligence. Even like she had a soul, but she's a very primitive intelligence with a soul. So she end up like because she's not limited by like human intellect and human like limitations, like human like programming. Like there's some programming baked in by the gods. Like she basically just rewrites herself until and improves herself until she had a body to interface with humans, and is at a level of intelligence slightly above humans, I guess, in terms of like actual emotional like a psychological understanding. She's similar to humans, but like in terms of like intellectual understanding, I imagine she's like way higher, just because she's basically the internet.
Nice.
Yeah, so anyways, that's the I thought that was really cool, like the way he wrote that in. I was like, that's I was like, it's kind of funny and awesome at the same time, and I hate like cults, so sorry, that was a little aside. Okay, is there anything else you want to talk about? We're about to run into 3 hours, and I think you have to work tomorrow, right?
Yeah, although it's not actually that late here.
Okay.
One thing on the subject, real quick, is I saw a study that was like being passed around Twitter a while back. That was on the subject of like neuroscience, just kind of not actually knowing how brains work. Some like neuroscience people did a study where they were like trying to determine like whether their methods for understanding brains actually worked or not. And what they did was they like, so all of these techniques that we use for studying brains, which are basically like input output, right? Like we're trying to see how it reacts when we give it this input, and then like see if we can like discern how it operates from enough probing of like results from stimuli. And so to test this, they tried it on a computer. They were like, can we understand how a microprocessor works using the techniques for understanding how brains work? And the answer was absolutely not. Nowhere fucking close.
Oh no. Oh no.
Which is an amazing study. Like, I'm so glad like somebody actually tried that.
Have you tried on other systems though? Have you tried on other systems that are complex enough?
I don't know. Like, I didn't even actually read the paper. I just saw like the abstract for it. I'm not a neuroscientist, so I can't really comment on it. But like, the concept is amazing.
Oh, that's so funny. I mean, we're making a lot of assumptions when it comes to the brain, right? We're kind of making the assumptions that like, that electrical energy is the way that energy like transmits. Like data transmits through the brain, but not necessarily. Well, neurotransmitters, the chemicals, as well as electrical impulses, are like what we assume like controls like it's a wiring in the brain basically. But we could find something else tomorrow. We could find a new substance that we haven't seen before tomorrow.
Yeah.
And, we really don't know. Do you want to talk? do you want to talk about? Let's see, what's this one time? Do you want to talk about the Do you want to talk about COVID-19 diabetes type 1, or do you want to just do you not want to talk about it because it's depressing?
I mean, there's not actually that much to talk about. It's just like, turns out a lot of kids are getting diabetes from COVID, which is fucking wild.
Yeah, it's like 50 something percent, right?
Yeah,
50,
I think so.
Like 50,
just
not
for,
51
like,
something percent of
yeah.
kids, but like the uptick of rates compared to like before COVID times. Turned out COVID is in some cases is a very good trigger for making your immune system hate your insulin makers.
Yeah, and like that has long been understood as like probably a part of the process for getting type 1. Like it's partly genetic. Like you have to have a genetic predisposition to getting diabetes in the first place, and then you need something that like initiates your immune system going haywire. And it was never like totally proven, but like the working theory for decades has been that like there's some kind of virus or something you can get, and the antibodies that you create when fighting off that virus are malformed such that they then end up targeting the pancreas cells after the real disease is eliminated. And like this has been sort of anecdotally seems to be true that like, hey, most kids, so like type 1 is almost always contracted in childhood, and like to the extent that it's called juvenile diabetes a lot of the times, and like it seems to be pretty common that like kids that get diabetes also like tended to have some kind of sickness, like nothing severe, but like maybe they just had like a stomach bug and they were you had like a stomach bug, kid was throwing up or something for a few days, like a few months before the diabetes stuff started, and like so like there's no way to like track that, like you can't go back in time and see what they had, but it did seem to it tracked in the sense that I'm confusing words here, but like it made sense.
It's one of those multifactorial things where it's very difficult to create a causal relationship, I imagine.
Yeah. But now what we're seeing is that like shit tons of kids are getting COVID because of Omicron, and also the fucking schools are open. And this is leading to a massive rise in kids getting type 1 diabetes, and like it's hard to draw real conclusions from that, like but like sure seems to be a thing that's happening.
It's gonna be one of those things where like 20 years down the line we're gonna find out like a lot of the unintended side effects of COVID and the vaccines and stuff like that, but yeah. I mean the alternative is dying, so what else can you do? What else can you do?
My extremely unscientific, I am not a doctor, thought is that it does seem to make sense that COVID would be one of the things that triggers it, because COVID is a coronavirus, and like there are shit tons of coronaviruses, and like it's literally like one of the common colds, and so like COVID-19 is a particularly gross mutation of it, but like the family of viruses it is one that like is everywhere, that people get all the time, and so if like the trigger disease for diabetes was already a coronavirus, that like would make a lot of sense, because it does seem to just be some random thing that kids come down with, and never something anyone could isolate. It's not like they got like malaria or something obvious. It's just like, oh, they were just sick for a while.
This could sound like a really dumb question.
That's what coronaviruses do. So now we have this like super coronavirus, and that's like triggering diabetes in a ton of kids. That feels like it sort of makes sense. Yeah,
and once again, incredibly unscientific.
Yeah.
But it makes I never thought to ask this question, but the way antibodies the way antibodies know what to look for is because they have these like puzzle pieces that like the protein spikes around them, or like, well, not sure they're spikes, but like a lot of cells and viruses have like these identifiers around them,
like shapes sticking together.
Yeah. The protein, the shape they're sticking out, those are the things that identify them, right? Those are like their fingerprints. And I'm assuming that all cells also have those things. Like those proteins. And then when you have type 1 when kids like are about to have type 1 diabetes, all the antibodies are doing is like they misidentify the cells because they have similar enough like their own cells have similar, their own liver cells that create insulin, pancreas cells that create insulin have similar enough like protein receptors on the outside, like little spikes or whatever.
Yeah, whatever the antibody is targeting isn't unique to the virus. It's also on these other cells.
Yeah, so that's how it's working. Okay, I guess it makes sense, because otherwise, if your cells didn't have it and other cells did, then bacteria would just evolve to not have those things, right?
Yeah.
Or viruses.
It's kind of surprising that doesn't happen more often, to be honest.
What,
like
evolving?
The fact that autoimmune diseases are rare is wild.
That is true.
Like, you would think with how like insanely effective the immune system is, it would like have more false positives than like most people go their whole lives with 0.
I think the reason why it doesn't happen that often is because autoimmune diseases are often fatal. Or at least like really, really bad, right? Like if they're not treated, they tend to kill people off faster than usual. And then if you're like, let's say, a virus or a bacteria evolving via like a natural selection to like have one that survives longer in the wild, you don't want to kill your host off as quickly as that. Maybe, I'm not sure. Or maybe,
I don't know. I feel like that's conflating a few things, because the evolutionary pressure is on the host, not the virus, because it's the host's immune system that's like the virus. The virus didn't cause the immune system, the autoimmune thing, in the sense that like the virus doesn't attack you by creating an autoimmune response. The autoimmune response is a thing that your body can do by accident.
Yeah, I mean, maybe what it is because like viruses tend to be like the same species for like an epidemic, for example, and the reason why viruses and diseases basically don't cause a lot more autoimmune system than already happened is because immune systems are individualized. Like people's personal cells are different, like their protein receptors are different from one person to another. So,
sure, but like the fact that works is still wild.
Yeah, but I'm just saying like in the sense that like the same, like two people developing the same antibodies, like there's a chance that one person might develop the immune disorder, but the other one might not. So maybe that's and then evolutionary, actually, you're right. Actually, yeah, there is no like this is weird. Now that I think about it, this is really weird.
Yeah, this is also not a subject that I know very much about, so I can't talk too much.
Yeah, all I'm doing is like imagining Tetris.
Do you know about graft versus host disease?
No, what's that?
Extremely, well, I mean, it's horrifying in the sense that it's like basically fatal, but it's an extremely cool way to die.
Extremely cool way to die.
Yeah,
Gonna have to put that in my dual quotes.
So your white blood cells are made in your bone marrow, right?
Yeah.
Do you know that?
Yeah.
So
all blood cells are made in your bone marrow, aren't they?
Yeah. When you get a transplant, it's like they do a bunch of weird like treatment to it before they put it in you, to kill all of the immune cells. Because so like when you get an organ transplant, you need to go on immunosuppressants, right? Because otherwise your immune system will attack the new organ. But also, if the new organ itself has immune cells in it, they'll attack you.
Oh wait, you told me about this. Okay, go on.
Yeah. And obviously that's bad, particularly if you're taking immunosuppressants, because then that just like makes everything more complicated. So like you do a bunch of treatment to like eliminate the cells in the organ before you transplant it. But bone marrow transplants are a thing, and like this is rare, like it's not supposed to happen, but it can end up happening. That like, if you get a bone marrow transplant, it'll just start making foreign immune cells, and it can. So then you're like, the normal like transplant rejection is your own immune system kills the transplanted organ. But the opposite can happen. The transplanted organ can win.
So just to clarify just to brief on what this is. So imagine you trafficked some immune cells. Like you have a city, and like a boat comes in, and inside that boat are like a squad of like Ultra Delta Force people, and then all those people just literally kill like every single like 1 million people in your city, like 8 people just
it's more like the Delta Force guys all, I don't know, I guess fuck a lot and like have a bunch of Delta Force babies and like train them to be a new bigger Delta Force, because like it's literally like it happens with a bone marrow transplant. So like the transplanted bone marrow is still a factory, and it's
a rogue state. It's a rogue state. It's
going to keep producing antibodies and white blood cells, but for the wrong body, and so they'll attack the body it was put into. And yeah, it's just like it. Your whole body just gets like destroyed.
It's like
in agony. But
if Japan won World War II, like if Japan won the Pacific War, this is what the closest analogy I can think of. The implants were better. Your immune system was weak and did not survive the winter.
Yes.
Implanted a super kidney or something. But yeah. Anyways, did you get to a part where it starts destroying your other cells too?
Yeah, that's what. I mean, that's what I was saying, but yeah, it wins, so then it's just like cranking out its own immune system that targets your entire body. It's just like, oh, what's all this foreign shit? We gotta fuck that up. And they just kill everything.
Oh man, it's like the Holocaust.
I'm not gonna touch that one.
I shouldn't have made that connection. It's not like the Holocaust. It's like a Command and Conquer mission where they make you like start on an island and you have to like take over the rest of the
Any analogy has to take into account the whole like you installed it yourself and then lost to it thing.
Oh, that's true.
That's because like that's what makes it funny.
Oh, it's Norton antivirus then. Wait, no.
your bone marrow transplant installs a crypto miner. You're like, oh god, fuck.
Why am I tired all the time? Why am I eating so much? It feels like I have tapeworms. New level sneak peek. Nah, this is a what do you call it? This is a test level because I'm working. It's just for testing a mechanic. Oop.
Is that cube is blurring the stuff behind it?
Yeah,
thus simulating scattering, as we were talking about.
Yeah, but in a really shitty way. But it
did you
works.
do that yourself, or is that a material thing that Unreal just lets you do?
It's a material thing, but it's a very specific hacky way you have to do it. I think it's technically an emissive. Like it's technically emissive, but it takes the scene texture. Kind of weird. Like it doesn't. I don't know how to explain it. Like if you're, I believe I had to make the base surface black, the base color, the transparency black or something. Otherwise they'll like be too exposed. And then so it renders it kind of on top of the translucency as a kind of emissive, like it blends it emissively, but it takes the scene texture. So if I had any color in the if I had any base color in the base transparency, it'll do that. So to get the color, what I do is I just multiply the spiral blur thing by the color to get this. The only reason I have this now is because this is supposed to be like a cloud of butterflies, so you can kind of see through, right? But because I don't have the assets for the butterflies yet, I have to do this. Like I have to make this
right.
I have to make this cube for now.
What's blurring it though?
It's called a spiral blur. I don't know how it works. I didn't do it. I don't know.
So you're doing the blur yourself though. Like that's not, you're sampling the scene texture a bunch of times in order to blur it.
I can open up the node and see what it does. I didn't write. I didn't write.
Oh,
the
it's
blur.
just a node.
Yeah.
So
I didn't
yes.
I didn't do it. I'm telling it to blur, but I'm not. I didn't.
All right.
I didn't.
So,
write the blur.
so the answer to my question is yes. You just didn't write that code yourself. It's
Yes,
somebody
yes.
put it
I've been
in
trying to
there. That
tell
makes
you.
sense.
I've been trying to tell you, but I'm trying to tell you how I'm trying to tell you how you're using it. Like, because I told you specifically. I didn't write this, but there's a very specific way that Unreal wants you to use it. Because otherwise it looks weird. And I'm pretty sure there's like a billion like Unreal games that don't use it properly. Yeah, so yeah, now I'm running into this problem where, like, I don't know if you can tell, but like I have this like sometimes like, so the target actor for this particular launch position is on a platform that's above this, but if I aim at it and I launch, it'll hit like the wall before hitting the target platform. So now I'm trying to decide whether
every single time I've seen that, I've just been like, ugh!
Yeah,
Like,
so I'm trying to
it's like trying to play Tetris in your brain. Like I want it to work every time, and every time it doesn't.
Yeah, so now I'm trying to decide whether I want to bake in some kind of parabolic arc into this. That makes it harder though. Because right now all I'm doing is I'm setting the velocity and I'm just letting it hit. Alternatively, I could set the position and then just like lerp over the position over time. But then now I have to figure out if I do that, then I have to I have to do the distance to I have to solve for time. I guess it's not that hard. I can just divide.
I mean, given this is all VFX stuff, like it's gonna be butterflies and shit. Wouldn't you want that to just be like, do a raycast, get the hit point, do a bunch of tech art animation to like make moving from one point to the other look cool? Like, I feel like introducing a reliance on physics and velocity would actually just make all of this much harder.
Yeah, the only reason why I might want to do that because I'm thinking it might be cool if the player can kind of move around a little bit and then pick up stuff on the way there, so it's a little bit more interactive. Like when Sonic like goes on the rail and then you can like kind of move around the rail to like pick up coins or whatever.
Right.
I could what I was thinking about doing is I could create some kind of parabolic movement that it will always follow, and then you can kind of offset from that position, so it's the same thing as a rail. Or I can try to kind of force some kind of parabolic arc, or I can just kind of make it like snap if it's close enough. But that last one probably gonna look pretty bad. I'm trying to decide what would be the best way to go about doing this.
I mean, when we were talking about it before, I would have envisioned it as a straight line because it's really fast. Like, it's like a gunshot almost. Like, you just go bam and you're at the location. So I would think like an arc would make that less punchy. Like, you'd want to do it in a straight line.
I could force level.
Like,
go on.
Why are you hitting the edge? Is it just because the target that you're aiming at is
yeah, let me go ahead and just make.
Like,
let me just go ahead and make the target
into the wall because the walls in
yeah,
between
that's
you and
basically
the
it.
target?
So I could solve that problem by just letting the how to make this visible inside the how to make this visible in the world. I could solve this problem by just like enforcing level design to not let anything block you.
Yeah, I would think that would make the most sense because you're always doing it from fixed points to fixed other points.
That's true. Like, let me just.
You could also just not have collisions until you're right in front of until you're at the end point.
Well, I mean, I could just not have collision at all if I
Yeah.
Because if we know what the endpoint is, we don't technically need collision. Yeah, let me turn it off and see how that feels.
Because like, if you're a cloud of butterflies, no one's gonna care if you clip through the corner of a triangle.
Yeah. I guess I have to make this if I were to do that and make it to I'll have to make this level a little bit more clear as to how you're supposed to use it. You're supposed to stop it with a wall. You can't stop it with a corner or something like that.
Yeah, when we were talking about this originally, I was kind of envisioning the targets as the targets are always walls. Like, you shoot yourself into a wall, and that's where you do your like impact animation, and then turn back into a person, and you're like maybe a foot or two above the ground.
Yeah, let me see how that feels. I'm just gonna go ahead and turn off collisions on this for now.
Because if you're aiming for a wall, then like naturally you'll just be aiming high enough up that you're unlikely to hit other things.
Turn off collision on these. Turn off collision on these. Turn off collision on these. Collision on these. Okay. Modify the level. Invisible rail sounds like a good idea. Yeah, I thought about it. For all the reasons we just mentioned, this would be the easiest thing to do, so I'm gonna just do this for now. Because I think even if we were to go the invisible rail route, we still have to have a wall for it to hit anyway. So, box. So I forgot to mention this, but Dew is also the one that I talked to figure out what to do with this. For this, I forgot whether we talked about it or not, but yeah, I talked to Dew about like what to do for this particular thing that the level designer needed, and he was the one that came up with, yeah, what if we just make it cool? What if you just make it explode because video games, you know? So whenever there's a random cool like a mechanic in Mahou arms, there's a at least 20%, no, I mean not 20, maybe like 10. There's a 10% chance that I stole it from him, or I talked to him about it.
It's not that high.
Okay, yeah, maybe you're right.
It's just quite... this and the incense burner.
That's true. Incense burner is a cool thing though, because like after you start talking about the incense burner, I was able to start thinking about other Catholicism things. You know, it wasn't just the incense burner.
How's that chain animation going?
I haven't done any animation work on her yet. Cause I haven't done any prototyping, I should have said, because I don't have a model yet. And
sure.
I think we're gonna have to do it though, and I also have to talk to the So after I came up with that design, like as usual, like you come up with a design and everyone's like, "Yo, I think we should do this. We should do this. We should do this." So we need to have a big meeting to figure out. We need to have a big meeting to figure out what we can do and what we can't do, and then get everyone's ideas in and then figure out like what to actually implement and how to implement it. So
sure.
God,
I'm so jealous watching you just have a BSP editor.
Oh yeah, there's no level editor in Unity.
Nope. They just decided games don't need those. You should make your own.
So it's funny because when we were talking about medical stuff,
that's why every Unity game uses terrain, because like height field terrain is supported at the engine level.
Oh, that's why.
So like every like student game or like little like jam game you can get on itch or whatever, like the basic way you move around the world, instead of being BSP boxes like in Unreal, it's terrains, because Unity doesn't have BSP boxes, but it does have terrains.
That's so backwards. Terrain is generally considered harder to manipulate than like BSP, I think. Especially like
it's not at all fun to work with.
Because that's why you have to have like sculpting tools for terrain and stuff.
Yeah, they made those. They're just not very good, but they exist.
Saving, and this takes forever. There we go. Let's see how that feels before I do anything else. Okay. Whatever tool is available is what's used. Unless you have someone that makes tools. Nope. Oh. I have to do detection, don't I? I guess it's cheaper.
I'm watching the stream on the stream delay, so I just saw you go through that wall. That's great.
Yeah. I think I should be streaming in low latency mode, but there's still like, I think 10 to 30 seconds. I can make it so
that is what happens when you turn off all collision.
Yeah, so I'm trying to figure out.
Collide with things.
But
I mean, like you did, even with collision, like you solved the problem just by putting the walls there. Like aim at the wall, not.
Yeah, but I'm trying to. I guess I don't really need collision though. But I guess I'm just trying to figure out which is faster. I guess I can use a collision detection to get a hit event, or I can go ahead, or I can just check for distance to the target. But I guess checking the distance.
Are moving collisions a thing in your game?
Moving collision, as in like objects that are moving have collision?
Yeah, do you have physics objects? Do you have platforms? Do you have collisions on enemies?
Yeah, well, enemies don't.
Then you should probably turn off collisions so that on the off chance that something ends up in front of the player while they're in butterfly mode, it doesn't break the entire game.
Okay, that is a good. What do you call it?
Unless you just want that as a speedrunner strat of somebody just like permanently locks themselves into butterfly mode by bouncing off of a crate launched from an explosion or something, which would be kind of awesome.
I'm just gonna set up a timer then. So I'm gonna as soon as it's launched, I'll have it check for collisions about 1 every 30 seconds. No, not 1 every 30 seconds. That's nothing. 30 at 30 frames per second, and then I'll go over here, custom event, collision, target check. So every time this ticks, I'll check for the distance to a target. Oh wait, now I have to figure out how to get all the targets. Okay, I can use the really fast actor tagging system. Get actors by tag. Tag with tag, and then the tag for the target is BC target. Actually, I only need to do this once. I only need to do this one to get when the thing spawns. Okay, go ahead and stand shade all our actors. Targets. Potential targets. And then what I can do every time this ticks is do a for loop. No. For each loop with break. And then we'll check for... Did it hurt you as a normal programmer to watch me program with nodes? Or...
Nah.
Okay. I know it hurts some programmers, but I wasn't sure if you were...
I don't like nodes, like, at a personal level, but, like, I understand why people use them. And I don't know enough about, Unreal's object model to have opinions about, like, the approach you're using here, so...
I really like it for
if you were writing a
prototyping.
shader with a node graph, I might start having opinions.
Oh, okay. Yeah, I do that a lot, actually.
Well, that's like the only way to write shaders, unless you go like way out of your way to do like custom HLSL stuff.
Yeah. The thing I hate the most about
I
Unreal
mean,
is
I would
that-
have opinions in like what you were doing. I wouldn't get mad at you for using nodes because it's
Oh,
the
okay. I
only
thought
option.
you. I thought
But
you.
I
I
would
thought you said you'd get
understand
mad.
what you were doing, and then I would be thinking about what you were doing, and that would result in opinions.
Ah, okay. I thought you meant opinions as in I have negative opinions. Let's see.
That would be a possibility, but they wouldn't be caused by the use of the material graph itself.
Okay, let's see. Get distance threshold. I don't need a hit event anymore. Let's go ahead and get. I'll leave this here because it's never gonna trigger anyway. Distance threshold. So if it's subtract vectors. Oh. So get actor location. Oops. So we need to get this one and then this one and then so we get the distance to that actor by subtracting their location vectors. And then getting the length of that vector will get us our distance. Length, vector length. And then we get that, and if that is less than or equal to our distance threshold. Oops. We'll go ahead and assign our actually, do we need to? No, we don't even need to assign a target. We can just immediately stop this thing. Okay. We can go ahead and set our velocity to 0. Sequence. We'll break our loop. There's one thing I don't like about nodes, like these wires. You have to like care about the wires. I don't know if
Yeah.
I don't know if I dislike that, if I like that more or less than having to care about white space to make the code readable.
My opinion with nodes is that you should be able to name wires.
Oh, you can.
You can name wires?
Oh, you can put comments on the reroute nodes. But I don't know. You can rename the whole wire. Like you can put like a little note, like a little comment here, like you can do that.
Yeah.
And then you can also put a you can put a little box around here, like you can put a box.
Can you make a redirect that like teleports a wire?
Oh no, no, you have to use events for that. You have to create an event. So what you have to do is you have to create a oh, not that custom event. So you have to add a custom event like this, and you have to call that event.
Oh, gross. So there's actually like a performance overhead to it.
Yep.
Yeah, like what I've slowly realized of like how I write code and how graphs work, particularly after like occasionally having to translate shaders between graphs and code like back and forth. The way I write code is like, particularly because I'm doing shaders, so there's a lot of stuff that's like mostly just math, and I'm not a mathematician, which is to say I'm not an asshole, so I name things. So if there's a bunch of math, I'm like, okay, this chunk of math gives me, like, I will give it a variable name that describes what the result of this output is. So if it's like an SDF thing, it's like, okay, here's the distance to the circle, and I'll like name it distance to circle. And then when I'm doing the ray marching code, I'll be like, here's the math that gives me the current position. And then my like hit check will be like distance, like doing a comparison between these two named variables that are like my position and the distance to the thing. So like the further down you go in the code, the more English it becomes, because every logical piece of code has a name associated with it. Like you do a math thing that produces a value, you name what that value is, and then every time you use that value for something, you refer to it by its name. And that makes your code really readable, even if you're doing a lot of very complicated math stuff. And you can't do that with nodes. You make a big pile of nodes, and like the closest you can get is put a comment around the big pile of nodes that says what that pile of nodes outputs. So like you do your distance check in your nodes, and then you put a big comment on it that says distance to the surface or whatever, and then you have a wire that just like dangles out the end of your comment block. But that wire is just like a wire. What I want is that wire to have the name on it, because it's not the nodes. Like the nodes are a bunch of math. Like the comment tells you what that math outputs, but like all I care about is like I want the return value of all those nodes assigned to a variable, like I would write in code. And like the wire, to me, mentally represents like the named thing. Like you have this big block of nodes that result in a value, and then you want to use that value in other places further downstream. So like I want the wire to be named, because then I can, like, when the wire is plugged into a input, like it says right on the connection like what named thing is going into it. Like if I do a distance check in a node that takes 2 positions, I want the input to that distance check to like say input A is receiving a wire that has the distance to the surface, input B is receiving a wire that has the distance to the camera or whatever, like whatever the two things we're comparing, right? Like you want the name going into the function that you're calling. I don't want to have to scroll backwards to see where this wire came from to see what the wire represents. I want to look at the node and see what arguments are being passed into it.
So
does that make sense?
How is that different than a variable?
It's basically the mental model is that wires are variables, nodes are functions, wires are variables. Node systems always let you name nodes or name collections of nodes to treat them as themselves function, but they never let you name the wires. The wires are just anonymous data values getting tossed between functions, which works. But like, if you could name the wires, it would make the node graph so much easier to read.
So you mean you want to be able
look at
to
any
name
downstream node and know what is being passed into it without having to read the rest of the node graph.
So you mean like you want to be able to like this thing? You want to be able to see do you want to be able to make your own type of data, or do you just want to be able to name this wire?
I just want to name. The data type is already communicated by the color or whatever. But I don't know what you're passing into that. Like, I would have to scroll left and go read all of the upstream code of that yellow wire to see
okay, that makes sense. Okay.
What is producing the value in that wire to understand what information is being carried on that wire. Whereas if the wire just had a name on it, then it would be like reading code.
Hey,
you would have the advantage of nice.
I don't know why she stopped.
You would have the advantage of like the fast iteration time of nodes, but you would also have the readability of code, because like well-written code is much easier to read than a node graph, in my opinion. Like, reading other people's nodes is a fucking nightmare.
It's sometimes true. I guess I've written a lot. I read a lot more bad code than you, I guess. Why is she not falling? Is she colliding with this thing? No, she shouldn't be colliding with the thing. There shouldn't be any collision. Oh. Is she colliding with the target? No, this has no collision on it. What is she colliding with? Oh, is it this? What on earth is she colliding with? She can't be clipping through the thing, right? I don't know if you guys have seen much game dev, but like 90% of game dev is being stuck on stupid things like this. Why is she not falling?
Yeah, you wrote too much code at one go, and now you're doomed.
The issue is it's like it's all code that I had to write to get this to even function.
Yeah, no, I didn't mean that as a personal failing. I meant like you were placed in a situation where you had to write too much code, and now you're fucked.
Yeah, there's no blocking collision on here, huh? It's just not being set to falling. Set movement.
Time to put a print statement after every node.
Well, I know what it's doing. That's the last thing that I did is teleported the character, so I know where it's breaking. I just don't know why the character isn't falling. Let's try. Try forcing the character in falling mode. Bloop. What? Why are you stuck? Okay, what if I destroy?
Like inside of the wall? Can that happen?
I don't think so, but I'll just raise the distance threshold so it's impossible. I don't think Unreal lets you do that. Let's try it. Yeah, that's not it. If I could do this, like oh wait, no, that's not it. Like she's not even touching the wall. That's really weird. Why? But why? Well, I just destroy this actor. I shouldn't do this immediately, but let's do it anyway. Let's try it out. Unreal gets really pissy if you like try to destroy stuff too fast. Like when there's still logic running inside of it. No, that's not it. Huh. Why? Huh. I don't get it. Is it because this is breaking and so not executing the right? No, that can't be right. It's gonna be some really dumb reason.
This is why I don't stream. Because if I'm programming, it's just this.
It's more. I feel like it's doable if you know to comment on. Okay, what if I teleport? If I just wait a little bit and teleport? Delay. We delay like half a second and teleport. Oh my god, we are going.
Amazing to me that they have a delay node, and it also immediately makes me think that like if you're not careful, you can just like make the most nightmarish code imaginable by overusing delays.
With a billion like race conditions and everything. I have done that in this game. Especially with the stupid like the switching between the modes. Oh my god, that's like the most annoying bit of code in this whole game. Switching between the modes, like the modes on the character. Oh my god, why are you not working? Mom!
Unity has a way to like delay things like that, but it's very inconvenient to use, which enforces that you only use it where you actually need it.
How do they make it inconvenient to use?
Well, like they don't have blueprints, so it's all from code anyway. But they call them coroutines, and they're just like events that fire later, basically give you a callback or some other thing after some amount of time has passed, and they're a weird syntax and require like just enough boilerplate code to make you like not really want to do it unless you have to.
What if I don't use the teleport? What if I just set position? What if I just set actual location manually? Maybe teleport is breaking. Even though the teleport one is the one you want to use because it's the one that tries to not have your character inside of a wall. Let's see. If this works, I don't know. I don't know what's happening if this works. Oh, I think I know where it is. Hold on. Get game mode. Is it because I'm in cinematic mode? Maybe that's it. Oh no, the consequences of my own actions. Let's see. Oh no, the consequences of my own actions. Ooh, okay. Cast to game mode base. Yeah, another annoying thing about the way data is structured in Unreal is you have to do a lot of casts for stuff that like aren't in the base game because of the base like this is a function that only exists in my child game mode, but there's no like get this particular game mode immediately function, so I had to use this other one. And then I have to cast it to that particular type of game mode. It's annoying. It's not it's a little bit annoying, not terrible, but it's Huh? Huh? Why? Watch it. I'm gonna end the stream, and like in 1 minute, I'm gonna like 1 minute after stream end, I'll have solved it. No, it wasn't that. This is really weird. What if I just... This makes no sense to me, but what if I just swap these around?
Just start connecting nodes to other nodes.
I'm gonna do it again.
Run some wires to some other places. I'm sure that'll solve it.
This is how I solve half of my problems. Ooh, whoop. Did we get out to possess that character? That makes no sense. Where's my player controller? There we go.
Maybe isolate your teleport code from your raycasting flying cube code. Like, see if you can successfully teleport the player to another location.
True.
Without worrying about all of the physics stuff.
Yeah, maybe. Oh! Wait, what? Is it just a possess? Really? Does the character not move unless I possess it? Oh! For optimization, Unreal turned off physics on characters without a controller. So it was that. Okay. I can do that. I can do this. I can teleport And then I don't have to worry about falling because it's gonna immediately go into fall. And then the moment I possess the character, okay, let's copy this code. Update pawn, and then I need to redo this, and then I need to do this, and I also need to set the view target, and possess, and unpossess. I don't know why I had to do that, but I had to do that for some reason. Where's the cannonball? So I had to unpossess myself, and then I have to okay, I should instantiate this to the controller first. Yeah, I understand why you did that Unreal, but man, that was really annoying. Okay, so we take this and call this the controller. There we go. Take the player controller and want to take it and then possess, and then get the player, and then from here we want to grab the slave camera because I made a different actor, and we want to reset the camera, set the view target. Yep. Okay. We'll take the player and get the slave camera. And want to reset the camera and then set the view target. Possess, reset camera, set view target. And then we want to update the pawn. And then get our game mode. Cast to game mode base. Okay, as soon as I get this working, I'll end the stream. I'm glad I got a little bit of work done today.
Yeah, I just had to stop talking.
Okay. Update the pawn. We'll update the pawn on this. Yep, of course, that's not a controller. This also needs to be here. Target new view target. It also needs to be here. I'll clean that up later. That game mode needs to go here. Would that work? Please work. Please work. But the talking's what made it interesting? Yeah. Oh, yay!
I still have the stream delay, so I get like spoilers. I found out that it worked from you yelling before actually seeing it.
No! Look. Why did resetting the camera there? I guess I can wait. I don't have to reset the camera. Let's see what happens if I don't reset the camera.
So is collision still off? Like if you do clip through a corner, will it cause problems?
It won't, because the teleport code will move you out to the closest part. And as long as this thing is like right here, as long as it's not like embedded in the middle of that object, it should be okay. It'll try to like the teleport code tries to move you towards the nearest valid surface area, like a valid area where you won't clip into something. It works pretty well. I don't know how it does it. Bloop. Yeah, I guess it doesn't need the reset camera code. The reset camera node. Bloop. I don't know why it rotates. Actually, wait, let's see. Is it always rotating? Is it always facing that way? Oh.
Earlier it seemed like it always spawned the character facing the same direction.
Yeah, let me double check. So it's facing that way. Oh, okay, it is. What would be the best angle to rotate the character to? I guess away from the wall would be the best way. Okay.
And that'll
So
depend on like your butterfly animation and stuff, presumably.
yeah, but I mean, I guess if we have the camera facing, if we have the character facing towards the wall, there's no way the camera will be clipping into the wall. Yeah, let's do that for now. I can always change it later. Let's see. So where's my teleport code? There we go. The rotation is set to 0. That's why. So we can get
like
our...
depending on how elaborate you want to get, you might even have like a landing animation where she turns around or something. Anyway.
Yeah. For now, I think what I'll do is I'll just take the opposite rotation of the velocity and then orient the character towards that. And then so we need to figure out what our start velocity is. We need to instantiate it into a variable. Starting velocity. We know that once we launch the ball, so we have to put it here. And we can grab our starting velocity. I don't know if I need to normalize it, but I'll normalize it anyway. Normalize. Convert that to a rotator. But we only care about the yaw. So we'll split this. We'll put the yaw over here. And that should be...
And you get to reason about a consistent up vector. It's so unfair.
Wait, you don't have a consistent up vector?
Only because I'm doing shader stuff, so like I'm always dealing with like the surfaces of meshes, which can have any arbitrary orientation. So like, I can't ever just like get a facing direction by just like cross product with the up vector or something. Because what if your
because you don't have an up
vector is also up?
I need to figure out how to reset the trigger after use. Okay, there we go. Re-enable trigger after use. We'll go ahead and collapse this into a function. There we go. Re-enable butterfly cannon. This will allow us the overlap trigger to work again. So after launch, we should re-enable the butterfly cannon. Okay. There we go. I hope I made my code smart enough that after I launch it, it won't let me launch it again. Okay, good. My code was smart enough. Okay, there we go. Now we go back here and try to. Oh, perfect. Oh, it's not destroying these yet, so I have to figure out how to destroy these.
Is it relying on physics to just to detect the landing, or is it doing just like a raycast?
There's no physics. Well, for the character landing or for the hitting the wall.
Hitting the wall. I guess the actual question I'm asking is, if you turn up the movement speed to like 1 billion, will it still work?
We can try. I think there's a little bit of the tick is not at the same rate as a game tick, so it potentially can go above that distance. I could do
so it is physics based, so it is possible to tunnel.
Yeah, but but the ending location is based on the target, so the character can never end up the character always teleports to that little icon. They never teleport to the they'll never teleport anywhere other than that area, so the character will never be able to go inside this. The only thing is
you'll get like a frame where you overshoot and then teleport backwards to the correct location.
Yep, I guess it'll work up to. Yeah, I guess yeah, there might be like
unless you can like move fast enough that it just misses the collision entirely, right?
Yeah, if it somehow if it somehow completely misses that, I guess it's possible. I guess I can kind of mitigate it by increasing the radius at which it checks, but It seemed to be working pretty well at 30 frames per second. I guess the only upside is the only time they might not work is if the frame rate is like ridiculously high and you'll see a little bit of overshoot, but it'll still be able to detect. Or if the frame rate is so low that it just somehow misses the check completely. But I'm not sure the frame rate will ever be that low. But
yeah, no, I'm just thinking about this as like. This is like a gun movement, right? Like you just go bam and launch across super fast. So.
I can try really fast. Let's give it a shot. I think because it's like a butterfly cannon, it's a little bit more forgiving. You can be a little bit slower. But if it's really fast, then where's the velocity? Where did I stick this?
I mean, you're the one making the video game. I was just thinking about it as like most of the cool VFX like is the impact on the wall. Like you push the button and you go bam and hit the...
Okay, I broke it.
Oh boy. Yeah, I just now saw that.
Okay, I can't... sometimes
that wasn't
it works.
Very fast either.
I think it's... Okay, let's... Just in case, let's just raise the threshold. I guess what I can do is I can always I can add a check. Like if it runs out of time, it'll teleport anyway, just in case. Just in case the player happen to hit a spot where like they just happen to have like a frame jump during that particular spot. Okay. And then so it doesn't just completely soft lock the game.
I don't really see why this needs to use physics at all. Like you do a raycast to see where the hit point is, and then you just move the thing that distance.
That is true. But if we do physics, I don't have to calculate how long it takes to lerp the object. And pre-compute the cap. Yeah.
That's one multiplication though. Like.
Fine. Everyone telling me to pre-compute it. Fine. I'll lerp it. Okay.
Like it's distance to target, and then you move at you get distance in meters. You move at some fixed meters per second. So if you want to get seconds, you would take the distance and divide by the speed, right?
Yes.
And that would tell you the amount of time that your lerp should take.
No, it's one of those things where like for some reason that kind of math, I understand it intuitively by programming, but I don't understand it intuitively by talking about it. It's weird. I know it's weird.
No, it makes sense.
I guess I don't need the end position because the start position is just the starting position of the And how do I want to figure out the... Do I want to input a time, or do I want to input a... I guess I want to input a speed, because the times can be variable depending on the desired speed.
Yeah, I mean, you could make it a constant time, but that would just mean you go faster over longer distances, which, like, could be interesting maybe, but, like, it would also feel weird because, like, shorter distances would move slower.
Yeah.
So you'd be like, oh, why am I going slow?
Guess I can put his desired speed. Opal hates pre-computing past as well, knows the pain of this. It feels dirty pre-computing versus the purity of simulation. I don't feel dirty doing pre-computing because I know simulations are ass.
Yeah, I would say exactly the opposite, because simulation is some fucking mixed time step. Physics is running at one frame rate and game is running at a different frame rate, and like collisions can tunnel because you don't have continuous collisions. Like doing it with math feels much nicer to me.
Yeah, yeah. But because of the way game engines are made, like it's easier to set up a simulation if you're like a newbie. If you just like me, just getting something out quick, it's easier to set up a simulation. But it's in the end, it's way better to just set up the pre-compute thing.
I live in such a weird domain of game dev too, because my own game is a custom engine, so it just doesn't have physics. And then the thing that I do at work, like we've almost never used physics because we're always doing just like weird stuff like wires inside of tubes or like eyeball surgery and stuff where like
The physics are really weird.
having
in
a
that
physics
situation
engine
anyway.
wouldn't help. So I forget that like, oh yeah, if you're a normal game developer making a third person character game where you run around and jump off of objects and like, oh, then you use the physics engine to solve problems. Right.
Unit. Can I talk about how like unit direction vector is like something that everyone except me understood? So I was like, what does this node do? Like, no one told me that just literally the direction of the vector. Like, why do a unit? A unit just means like normalized. I'm just like, man, this is what happened. This is what happened when you don't fucking take like calculus 1 or. This is what
I gotta
happened when
be
you-
honest. I'll take your side on that. I would have to think for a minute about what that function means. Like,
Okay,
why is it
never
not
mind.
just normalize?
It's not just me that's dumb. It's the world that's wrong. Got it. Okay. Desired speed. So we have the unit direction vector. That will give us our rotation vector.
I guess because normalize would be two things. Like you subtract the two and then normalize them, and that would not make very much sense to read in nodes. And that's part of why I hate nodes, is because like math just looks insane. But like the way Unreal gets around this is by making a node for every action you could possibly think of. So of course they have a get unit direction vector node, because the alternative is a bunch of nodes stacked together that looks ugly.
Throw humans at the problem. Okay. I need to make, okay, I have the starting position. I know what the end position is going to be. Let's go ahead and make this a variable. Ending position.
A few months ago we had a shader that used, you know how Houdini can export those like vertex animation textures?
Yeah. Vertex animation means the vertices move, chat.
Yeah,
And
you do like your simulation for like some destruction physics or whatever offline, and then you bake the positions of all the vertices into textures, and then you have a shader that just reads those vertices. So you get like arbitrarily complex animations for a constant memory cost, which is very cool.
Your constant memory cost is a texture.
Yeah.
Did that for chat. Didn't do that for you. I know you know what that is.
So like Houdini wrote like a whole system for that, and then they wrote a Unity shader graph, because like Unity has their own version of Unreal's material graph now, but it's like really half-baked. So the like side effects, the Houdini devs like made a Unity material that implements the sampling to use one of these vertex animation textures, and for reasons that aren't worth explaining, because it would just be me complaining about Unity for half an hour, that being a material graph made it useless, so I had to like turn that code into a shader, and it was absolutely nightmarish. Like they took like a fairly complex bit of math, but complex in the sense that it's about 100 lines of code, but if you've dealt with code and nodes like interchangeably, 100 lines of just pure math turns into like a nightmare of nodes. Like one line of math is like 6 nodes. So like they just had this like unbelievable rat's nest function that like some guy at Side Effect probably like wrote out as HLSL and then like translated into a node graph themselves. And then I had to do it the other way. It took like 3 days of just like fucking with this stupid graph to like trace all of the paths through it to figure out like how to just write this as code. And yeah, I ended up with like,
and it's like kind of broken too, right? Like because it's like
no,
a new.
it worked fine. But like
Okay.
it's like 100 lines of code. Like you can fit it on a screen and read all of it, and it like, oh, that's straightforward. I understand what this is doing. But like it's in this node graph that's like just hundreds and hundreds and hundreds of nodes with wires going everywhere. Like, oh
Yeah, like sphere tracing is one thing I would never do with nodes.
yeah.
Oh god, how do I do this again? So I have the desired speed. I have a timeline that takes 1 second. To figure out how long the timeline is, I need to get the distance for this. So I need to get the length, distance, subtract, vector. And then we get the length. And that's a vector length. So so I have to divide the...
They have a get unit direction vector, but they don't have a distance function?
Yes.
What the fuck? HLSL has a distance function.
Yeah, I mean, it just subtract, I guess. Oh no, I guess you're right. There is no, whatever. I can make one later. Okay. I say later, but I'll never make it. It's okay. So we have the length of that. So we have to divide the speed by the length, because the longer it is, the slower it needs to be. I think that's it. Okay.
Yeah, and you can also just think of it as like canceling units, because like the distance is meters, the speed is meters per second, meters over seconds. So if you want to get seconds, you have to divide, because that flips it upside down, puts the seconds on top and cancels the meters.
And I'm pretty sure this is gonna be too fast, so I'm gonna divide it by I don't know what number. I'm gonna go 1000 just to see what happens.
Divide what by 1000?
Because I'm pretty sure this value is gonna be too fast, because it's setting the play rate for the timeline. So actually no, not by 1000. I'm just gonna divide by 4 just to see what happens. Because to just scale the whole thing down by 4. Actually no, wait, I'll just multiply it. Okay. Because divides are scary. Okay, I can multiply by 0.25 for now just to see what happens. Because I don't right now. I don't know what units these are in. I probably don't need to do that, but I'll do it anyway.
I don't know why you're doing this.
Because this is a play rate, so if I don't divide, it's gonna be very fast. But if I want to slow it down, I can do it here. Like manually slow it down, I can do it here. Wait, I can just do it with the desired speed. What am I doing?
Yeah, you want your actual meters per second to be in meters per second.
You're right. I am dumb.
So your output of your divide node there is seconds, and if your playback, if your timeline is expected to take 1 second, and then you're passing in a number of seconds into it as a scalar, that will I would have to think for a second whether that will just work directly, or if you need to divide your play rate by your...
Yeah, I might have to do one divided by... I might have to do 1 divided by this instead of this divided by...
If you want it to take
0.5 seconds, I'm gonna leave that node in here for now. I'm gonna do the rest of the node here.
That means your play rate needs to be twice as long. Yeah, so you need 1 over.
Okay. I'm smart enough. I'm good enough at this now that I can kind of recognize that. Okay. I need to. This is the. Do I have anything here that goes here?
Oh wait, it's play rate, not play time.
Yeah, it's play rate.
So if you just plug it in and see if it works, and if it doesn't work, then do 1 over.
Yep.
It's one of those two.
Always have to do that. I just had to migrate this code a little bit. Give me a sec. I had to put it in. I can make this. This is the teleport player code, and then that is the destination location. Elapsed the function. Wait. Custom event. Teleport player. And then the location will be. Hey Shimatsu. Yeah, Opal, thanks for passing by. Good luck. Okay, let's see. Teleport player. Go here. And then over here, we will take this. Whee! Refresh node. Okay, now we take this. And then we want to set the set actor location. And then for each one, lerp vector. Why do you guys have to be so correct? Look at what you made me do. You made me make my code better.
I like lerps.
Lerps are nice. They're deterministic.
So easy to think about.
Take this. And at the end of it, I'm going to teleport the player. And grab the ending position. And that should work.
Might have been too many nodes to add at once. We'll see.
Did I what? What did it?
Is it going the wrong direction?
Why is it going the wrong direction? Oh wait, I know why. Wait, no, I don't know why. Oh, okay. Oh. I look at my old code and I realized that I used this to get a direction vector to get a velocity, but it would have been easier to just do the lerp thing from the beginning. Cause I can skip this conversion here. I'm like, I know where to go and I know where to start and where to go, and I change it to velocity, and I do all that hacking, but then in the end I could have just done a lerp at the beginning. Okay, here we go. Hey! Hey, I think it works. Like, let me slow it down so I can have a better idea of, like, it actually taking longer for the long one. Oh god, it's so slow. Ooh.
This is about the speed you were at earlier.
Yeah, I think it's actually... Yeah, okay, it is working. So it's maintaining that speed. So if I set it at somewhere in between that 3000, let's see how that feels.
3000 what?
I didn't know what Unreal's velocity.
Oh wait, aren't Unreal's units like centimeters or something?
So is that like centimeters per second or is that meters per second?
Well, 3000 meters per second would be
Oh wait.
extremely fast. So I would assume those are centimeters, and you're going like 30 meters per second, which, like if you count out a second here, that seems about right. Assuming your character is 2 meters ish.
Yeah, she's 150 centimeters. Doop. Doop. Yeah. All right, we got it working. Thanks.
Yay!
Yay! Now I just had to make it not look like crap.
That's the fun part.
Yay! Bloop. Well, it's actually good enough for my level designer to start working on it, actually. So it's actually pretty nice. Like,
so does that curve, or like the curve that you're setting this playback speed on, does that mean you can like make it a different shaped curve so you have like an acceleration or something in there?
yeah, and try it.
Nice.
Let's give it a shot. Where'd I put it? I wouldn't. I guess I can still accelerate because like it depends on what kind of projectile it is, right? If it's like a bullet, then it shouldn't, like if it's a bullet, it should only decelerate. But if it's like if it's like a rocket, it can accelerate and then decelerate. Yeah, I don't know if I like that deceleration.
Yeah, you wouldn't want a deceleration.
Let's set that to linear. Is it a linear button? There's probably a linear button, but I don't know where it is. Oh, there we go. No! Oh well.
Yeah, there you go.
Yeah, I don't know if I like it. It's
Again,
accelerating.
I'm on the delay
either.
here.
Yeah, you should see it in like a couple seconds. I guess what I can do is I can do a cartoonish. Let's see.
I mean, you do need like some time at the beginning for the like transform into a butterfly animation. Whatever. You're good at your job. You don't need me to tell you how to do this part.
I was gonna do it here. Like it would go phew, it turned into a butterfly, and then like that's when you interact with it. That's what I was thinking.
Oh, like you're already the cloud of butterflies when you're aiming it.
Ooh,
that makes sense.
That makes it easier for me because I don't have to animate the character doing much either.
Yeah.
Let's see. I'm gonna try one more thing. I'm gonna see how I feel if I just put a little cartoonish thing right here, just a little bit. I can't even
like
see
shoot
it.
backwards a little bit.
Yeah, that's what I'm trying now. Ooh, that's not what I want to do. Probably a little bit too much. The issue with this is like this is a relative value. So if I oh yeah, let's not do that. A little bit too much. So it's gonna depend on the
I like the idea of it though.
I think the best way to do that would just be to it's like the best way to execute that would just be to use an actual animation on the butterfly pawn.
Yeah.
Yeah, and then we'll just
like do your animation and then trigger your LARP stuff after the animation is done.
I think and as far as moving goes, linear still feels the best. So
yeah, which is surprising to me because like that's my instinct is always the opposite of that. Like nothing should ever be linear. Because it just feels like the computer is doing it. But given that this is like a projectile thing,
you haven't done much of animation, have you?
Only like VFX, like tech art stuff, not character animation.
Yeah, so actually, when it comes to like actual character animation and like regular, like normal, like traditional animation stuff, linear makes sense where a lot of things are fast. Like I forget what it is. I think it's like mouth flaps. Like one of the easiest way to do mouth flaps is to open it linear and then like close it like with an ease. Like so anything that's fast actually reads better a lot of the time if you just make it linear. Which like it sounds counterintuitive, but it's just because animation is how you perceive the emotion. It's not really like animation as an art is how you perceive the emotion, not about what it's actually doing. Yeah. You can do a lot more stuff using linear keys than you would realize. So that's actually one of the most that's actually one of the ways animators detect programmers animating. So. They're like, yeah, you made like the term like too spliny is actually like used negatively.
Oh yeah, that makes sense.
So all right, I think that's it. Thank you for coming on the stream.
Yeah, thanks for having me. That was fun.
Yeah, super fun. We should do some other time when we have more topics and have more things to program.
Thanks for drawing me as an Arknights guy.
Yeah, no problem. You can use it for other things if you want. I don't really care. Where can we find you? We can find you on Twitter, right? That's it?
Yep, that's pretty much it. Amazing THEW at Twitter.
You'll be able to find him on Twitter at AmazingDo. Good luck on Aerobat. If you can buy it, can you buy it on Steam yet? Can you pre-order on Steam yet? I think you can.
No, right? I need to set up the actual Steam page for it.
Okay. So, but you are on the Greenlight
I got through
program.
Greenlight when like Greenlight was real, and then I went to like make the store page, but at that point you needed a tax ID, like you needed to have like a corporation in order to like make a Steam page. So I just never did that, and now it's like 9 years later.
Yep. Well, add it to your wish list, I guess. Beat the algorithm. Wait, no, it's not on Steam yet because there's no Steam page.
Yeah, it's not. There's nothing to wish list. You just have to follow me on Twitter and read my JRPG posts.
Yeah, read his JRPG posts and there's some grumbling about technology and stuff. I actually have a friend that's waiting for me to call them, so I will end the stream very fast. Let's figure out who we're gonna raid. Let's raid Hiraki Yu. I can't find another art stream that I know someone that I know right now. So let's see what she's doing. They're doing. Sorry. They've been streaming for 4 hours. Oh, they're still streaming. Okay. Well, everyone, thank you. My next stream will be what's my calendar? On next Tuesday. But I'll be on I'll be on Ray stream on Friday, and I think I'll be on chat stream on Sunday. So thank you everyone for, again, thank you too. I will see you
Thanks.
tomorrow in DM probably. My browser's showing. Yeah, it's fine. Thanks for letting me know. I'm showing because I was looking for Hiragi. Hope you have fun with Hiragi. Hiragi UVT. Did I get it right? Ah, Twitch. UVT. Did that work? All right, everyone. Bye bye.